Okay, so when we talked yesterday, we were running through the pieces around container architecture and how that could possibly fit in particular around ECS, which is one of the two official solutions now that you can use for containers. ECS and EKS are the two services. One is the Elastic Container Service. The other is Elastic Kubernetes Service. You know, one is industry standard, which is what the EKS service is. The other one is Amazon's proprietary ECS. But just to say this, ECS is easier to use than Kubernetes by far, even though it's AWS proprietary. But Kubernetes has more extensibility and more power to it than ECS will probably ever have, frankly. And also EKS, the Elastic Kubernetes Service, is industry compliant, whereas ECS, like I said, is proprietary. So we're going to talk a little bit more about that. Now, we did actually have a conversation about microservices, including the three things that make microservices really distinct, which is namely that you are taking an existing monolith and you are splitting it up into smaller services that are focusing on one business concern, like billing, you know, account profile management, inventory management, you know, recommenders, like my favorite top 10 lists. And you are isolating the business concern. You are making it independently codable, scalable, and deployable. And third, these services all talk to each other through well-defined published APIs, application programming interfaces. So they run across the network. We talked about how like different endpoints could lead to different sets of servers as part of using an application load balancer. So, you know, example.com/users/topics and/messages could all go to different places. And then we talked about X-Ray, which was used as observability tool, which you can actually stick inside of your application, and it will show you end to end all of the service calls being made inside AWS, including managed services, by the way. So pretty cool. And then we talked about containers as far as like a container is really just what was the thing that we said yesterday? If a virtual machine is OS virtualization, then a container is what kind of virtualization?
Application.
Yeah, application, process virtualization, right? Either one is good. And so it standardizes the way we package applications so that if you have the containerization software, you can now run this packaged application. Now, remember, there were two caveats I said that when you run a container, it is dependent upon, you know, what's underneath it. So there are two things that have to match with a container, especially if there's a binary in the container that's been compiled. What are the two things that have to match? Like if I'm running a Linux container that was pre-compiled for ARM, what does the host have to have in order for that container to work? What characteristics does it have to match?
The same OS.
OS is one. What's the other one?
The processor.
That's right, the processor architecture. So be careful, because like if it's compiled into a binary, it must match the processor. If it just needs an interpreter like Python or Java, just make sure the interpreter is on there for the CPU architecture and operating system. Sorry, the operating system can't be fudged, but for CPU architecture, if it's not a compiled binary, you can actually, if it's an interpreted language, you can just make sure the proper interpreter is on your system. In other words, what I mean by that is that if you just have Java code in there and just executing Java files for your application, you're not actually compiling it into like a static binary. What can happen is that you can run it on an ARM-based system or an x86-based system as long as the proper JVM is there. Hopefully that makes sense to you.
I thought the JVM is in the container.
It is in the container, but sometimes you can have multiple versions of the JVM available, right? And contingent. Now, just to say this, most people don't do that, right? What they do is they run one type of JVM inside a container, but you could actually make, you know, I've seen people do it where you can make your, like, for example, Java application CPU agnostic, but just so you know, that does increase bloat in the container, which is why kind of like the industry practice is to create a container per CPU architecture, per OS. So, but you can get away with it as long as you have the interpreter in there for the language, for the architecture. Okay. Then we talked about containers usually contain everything you need in there, including what was just mentioned as far as the runtime environment, virtual machines in this case, the Java virtual machine, not a real virtual machine, right? And then talked about how to split this monolith out and kind of like that concept. And we talked about the layers of abstraction around containerization. So when we mentioned that containers and microservices go together really well, because you're going to take a big application and split it into smaller chunks, and they're going to scale independently. This is perfect for containerization because previously these systems on the left were all running on a single virtual machine. You're maybe, 3 virtual machines if you look at the ones on the left. You're going to do the same thing on the right-hand side, but those machines are going to be distributed. Remember this kind of core quote as it comes to IT is that distributed systems are hard. And that is typically true, is that distributed systems are typically harder than consolidated centralized systems. And then we talked a little about the level of abstraction and how in the middle, rectangle / square, there's a guest OS that's being replicated many times just to host an application. Whereas with containers, in order to have an application, you're not replicating the guest operating system every single time. All you're doing is just running your app and your libraries and just isolating them so they can't mess with each other. Mess being the technical term for interfere. And then other apps just on containers and virtual machines. And I was kind of like complaining because it was like the Docker engine is listed there, which is actually totally fine if you're just running a single system. But if you're going to deploy this across multiple boxes, which is kind of what's implied here as far as like multiple virtual machines, Docker is not going to be your container engine. I know this sounds strange because it's like, well, Michael, aren't these Docker containers? Yes, they are, but they're going to run on top of Kubernetes. Kubernetes has the ability to run Docker containers without necessarily using the Docker runtime, right, per se. Well, that's not accurate, but the Docker kind of supervisor, if you will. So this gets a little confusing because this is what Kubernetes is built for. Kubernetes is built so that you can run containers across 5,000 machines, which is the largest cluster size that Kubernetes supports out of the box. You might think, well, Michael, why would you need 5,000 machines? I just did a project for the NFL, a proof of concept, in preparation for the Super Bowl in 2022. And we ran 49,000 containers across 5,000 boxes. So yeah, so it happens. So once we get past process virtualization and how containerization works as a general concept and why it works well with microservices, then we have to talk about the associated tools. And this is where we get into fresh content for containerization. So if you can imagine, let's say that these systems here are all Docker containers. Now, Docker containers are all based off something called Docker images. Docker images are just like AMIs. They are like bootable copies of the process. So this user service, this topic service, and this message service all exist as containers that when they are built for the first time using what's called a Docker file, they have to be pushed almost like code to a registry. Because if I'm running a Kubernetes cluster, as an example, and I've got, let's say a bunch of boxes over here in purple that are all meant to host these containers, these services, what's going to end up happening is that each of these boxes is going to want access, an arrow here, it's going to want access to be able to download this user's container, this topics container, and this message container, but they all live over here. So in order for Kubernetes to get access, think of this Elastic Container Registry as almost like a repository for container images. And so when you tell Kubernetes, hey, Kubernetes, I want to run 5 of the user service, 10 of the topic service, and 20 of the messages service, what's going to happen is that Kubernetes is actually going to pull those containers from this particular location, the container registry. And what it's going to do is it's going to pull and put one here. It's going to put one here, put one here, put one here, and put one here. Notice these are all on different boxes, and this is the user service. When it gets to the topic service, since I asked for 10 of those, it's going to run 10 of these containers spread across all of these boxes. For 10, by the way, there's a 10th box in here. So there's like 10 over here. And then last, because I asked for 20 of the messaging services, what it's going to do is it's going to run 20 of these services across the 10 boxes. And since there's only 10 boxes and I asked for 20 services, it's going to run a couple of them in, on the same box. Now they're going to be distinct and isolated, right? But all of those images that Kubernetes is running in those purple boxes, they're being pulled from here. They're being pulled from this registry right down here. So you have to have a registry of some type for you to pull images down, but particularly with Kubernetes. Now, here's the funky thing. By default, not using ECS or EKS, which is the Amazon proprietary services, if you say, hey, I want to do a Docker pull and I want to pull down like an Nginx image or something, what ends up happening is that you actually end up, pull this over actually. You end up going to the most popular Docker registry in the world called hub.docker.com. Now, what's interesting about hub.docker.com is that this is where you can find all of the popular vendor and open source images in the world. And this is a public registry that you can pull for free. But don't get me wrong, they're going to rate limit you. But let's say that one of your favorite pieces of software is Redis, right? Now, just to be clear, if you're here, make sure you use official images. I'm just going to say that. Please just use official images or a verified publisher. So this, by the way, is a Redis image. And if I click in here, if I run this command, docker pull on my system, it will download the bootable process, the bootable container image for Redis. It'll pull it onto my box. That's the same as what we were just talking about here with ECR, because ECR acts just like hub.docker.com. It allows Amazon services to pull off of this registry. So this registry contains a copy of all these bootable images. How do they get there? I put them there. So you have to put them there, or you can pull them from hub.docker.com and modify them and push them up yourself. It's up to you, right? But like here's Redis, for example. This is a Docker container that contains Redis. Now, one thing that always cracks me up is look at the size of this thing. So from AMD 64 to 386 to ARM version 5, this thing is no larger than 40 megabytes with the Redis software. Now, of course, this is an empty database, so there's no data in there. But I mean, if you add obviously 2 gigs of data, then the container is going to try and grow to 2 gigs. Now, you might have a problem because you need to store that data somewhere. So you need to add a volume to your container to make it persistent. But that's a whole separate topic, right? But no, just know that these tags like latest bullseye, 626, 626 bullseye, these all are different flavors of the various images, Docker images, that you can pull onto Kubernetes or onto your local Docker installation. Because just so you know, sometimes you're running Docker locally, but you're not running Kubernetes. Kubernetes is more for production deployments, but don't get me wrong, you can also run single node installations of Kubernetes locally. In other words, Kubernetes doesn't need Docker to run, and Docker can also run by itself, but Docker is typically not deployed as a piece of software into production unless you're using something called Docker Swarm, which is actually a different product. So it's owned by actually a different company now. It's not owned by Docker anymore. It's owned by a company called Mirantis. So you can pull these images and notice here that they're giving you specific commands on how to copy a specific version. Notice that there's Redis : and then the tag, which in this case is 6.2. So you can pull down a bunch of specific versions of software if you want. And to get these started, you just have to do a Docker run. That's it. Docker run Redis tag 6.2. And you can specify ports and you can mount hard drives to the containers if you want to. You can specify networking controls. You can expose ports if you need to expose the Redis port. So you want your host system to be able to get to it. There's a bunch of things you can do here. But all of this requires access to some kind of registry where you store container images. Sometimes referred to as Docker images, but technically it's container images. So that's what the Elastic Container Registry is for, is it allows you to push images to it so that your Kubernetes and your ECS and EKS clusters can pull down images to run. Again, who puts them there? You do. Now, ECR is used to store images. That's on the left-hand side. On the right-hand side, we've got some definition around Amazon ECS, which is the Elastic Container Service. Now, a reminder that the ECS is proprietary to Amazon, but it's a lot easier to use than the Elastic Kubernetes Service if you're not familiar with Kubernetes. Sounds like there's a question.
Mike, I have a question.
Yeah.
So for this ECR, can you have, for example, can Travelers have its own version of ECR so that it only contains Travelers images?
That's actually how it works. When you create an ECR registry, it's isolated to you.
So it's not something that a developer creates. It's something that probably a corporation creates it and then gives access to its developer to put images and retrieve images. Is that correct?
Agreed. Yes, that's exactly what happens. Usually ECR is a way station. Like for example, Arpon, you probably use Artifactory or Nexus inside your environment.
Yep.
And with the checkbox, Artifactory can be converted into a Docker registry. Assuming that, depending on what version of obviously of Artifactory that people are using. So the reason that's significant is that most people in an enterprise will push to their central artifact repository. So whether it's third-party libraries or Docker images or container images, you'll push to Artifactory. And then what will happen is that Artifactory will get replicated over to ECR so that the clusters over in Amazon can pull images, but not have to go all the way back to the corporate network to get it. If that makes any sense.
Okay. Yep. It
Yeah.
does.
Some people will take Artifactory, run it inside AWS, have two copies, one that's on the enterprise and one that's out on AWS. They'll keep them in sync. And then what will happen is the ECS or EKS will pull from the Artifactory copy that's up on cloud. Generally, most enterprises do not go across the wire all the way back to the corporate network to talk to whatever repository is internal to the company. So it just depends on how the architects want to solve that problem from a service offering perspective. But ECR is isolated. So that is isolated for Travelers use only. No other customer is going to see it. It is literally your own independent instance of a registry. Two things to note. ECS, just like EKS, can run in what's called EC2 launch mode or launch type, or Fargate launch mode or launch type. Why is it called Fargate? I don't know. I think it's a shopping district in the UK. I have no idea why they called it Fargate. They should have just called it serverless, honestly. So there's an EC2 launch type, which means you're going to use EC2 virtual machines as your underlying hosts for the cluster. And Fargate is serverless. So that just means that you have servers there, but you're not going to see them. Here's the difference, by the way, between the two from a operations and costing perspective. With EC2, if you launch 3 worker nodes, meaning 3 virtual machines, and you buy 4 processor 16 gig systems, and you got 3 of them, you're going to pay 100% of the cost of those 4 processor 16 gig systems. If you only launch 5 containers and those boxes are 30% utilized, then of course your return on investment is pretty bad. With serverless, a la Fargate, you only pay for the size of the containers that you run. So with the EC2 launch type, you pay for the hosts, not the containers. With the Fargate launch type, you pay for the containers. You don't pay for the hosts. You don't even see the hosts. So this is significant because if you launch 5 containers and they eat a gig of memory in 1 processor, you're only going to pay for 5 gigs of memory and 5 processors. That's it. Plus the cost of just in general having a cluster up, which is like 10 cents an hour. So, I'm a big fan actually of running this serverless because 1, you don't have to protect and manage all those EC2 instances. And 2, it's cheaper. But to be clear, Fargate has some limitations. It has some like space and size limitations, but some of the limitations are crazy. It's like you can't run larger than a 10 gig container, and that's old. I haven't looked at it in probably like 3 months. It's probably changed, honestly. You can't like run larger than a certain size of container, but I think I want to say it was 10 gigs. I want to say it just got up to 20, but I'll have to look that up to confirm the numbers. But there are some limitations, like you can't go above like, I don't know, 4 or 8 processors. But I just want to say, I'm kind of making fun of that because you shouldn't be running containers that large anyway, to be frankly about it. you're gonna, unless they're data stores, they're databases, which you might then run them that large. But even then, if you're running a distributed database, it's probably gonna be right at the limit. But regardless, Fargate does have a few more limitations than the EC2 launch type. So just keep that in mind. I'll actually bring up the documentation at our next lab and just make sure I can refresh everybody about some of the distinctions there. But I haven't looked at it in a couple months. Now, ECS does practically everything that EKS does for you in terms of like scheduling, distribution, deployment, monitoring, health checks, logging, trying to think of something that's auto recovery, like self-healing, that kind of thing. ECS is a really good product. It came out well before EKS was published. And if you want to start using containers, I recommend you use ECS. If you're going to go into production and you want to replicate the environment locally as well as in cloud, I do recommend that you use something like plain standard Kubernetes or even OpenShift, which is not a bad product, but it's a good place to start.
Michael?
Yes.
So if we were to go with the EC2 route, do we need to then install ECS on that EC2 instance ourselves, as opposed to using Fargate where just manage it by itself?
No, the EC2 instances are actually kicked off from ECS. So they're automatically set up and installed with all the software and configured appropriately. You can have unmanaged and managed nodes inside of ECS if you use the EC2 launch type. So the unmanaged boxes give you the rawest control over the system. The managed boxes, if you decide to do a managed ECS cluster, then you still could log into the system, but Amazon does most of the management for you. So they are still trying to make it as, in a sense, serverless as they can, but you still have access to the servers, so you're still responsible. But all the software is installed, the whole thing is set up for you. You're not rolling it from scratch.
Right.
Yeah.
Okay, thanks.
Yeah, even with the unmanaged systems, you're not rolling it from scratch. You say, hey, I want 3 boxes of this size, and ECS talks to EC2 to kick off the worker nodes for you.
Right, okay, thank you.
Yeah.
My question for you, how would you decide whether to use Lambda functions or package it into container and use Fargate, since they're both serverless and they can still scale up and scale down?
Well, if you're doing event-driven programming and you don't need something to run 24/7, and your workflows contain executions that don't go longer than 15 minutes, I would recommend you use Lambda, right? Lambda is going to be a much more highly managed option. When you run containers, you're still running, in a sense, tiny little processes that have to be managed, right? With Lambda, they only execute when they're called to, right? They're not running 24/7. So Lambda isn't really going to fail. The thing that's going to fail is that Lambda won't execute when you trigger it, right? Which is honestly really rare. So the difference there is whether or not you need a 24/7 running process that needs to always be listening and immediately responsive, or whether you can have it be a Lambda execution, which is part of a workflow. Every execution is under 15 minutes and you're fine. Right.
I mean, if I need something to run 24/7, then Fargate is probably not a good option anyways, right? I probably want to go to EC2 because it's always there.
No. Fargate is always there. When you start a container, it runs 24/7.
Okay, I thought it spins down all the way and then based on demand, it spins up.
No, that you're thinking of Aurora serverless, right? Aurora serverless just spins the system down, right, and spins it up, and you'll see milliseconds of latency. With Fargate, it's always running until you tell it to stop.
So you always have one instance of one container in Fargate always running. You cannot say 0, spin down to 0.
You could spin down to 0. Actually, have I ever done that? I think you can. I think I've seen that in documentation, but I've never done it. Usually if I'm running Fargate, I have a minimum of 1 container running at a minimum. Actually, it's usually 2, but usually there's at least 1 container running, and then it'll scale up to 10, 20, 30, depending on what the application is. I don't know that I've ever turned it down to 0. Usually at that point, it's like, hey, I think you delete it at that point, because it's either on or it's off.
But from an API perspective, right, you put something in a Lambda, you put something in a container. Yes, one is running 24/7 and one is running when it needs to run, when it's triggered.
Right.
Technically, it's still responding in the same way. So if you make an API call to a container, it will respond right away because it's up there.
Right.
If you're calling Lambda, it will also respond right away. It's just being triggered slightly different. So from the consumer's perspective, there's really no difference.
No, they're not going to see the difference.
This whole 24/7 thing, I don't really understand the value, to be honest, because Lambda is 24/7. It just gets triggered in a different way within that 24/7, right? So this whole distinction of 24/7 versus not, it's a little bit fuzzy, to be honest.
Yeah. Well, let me frame this up for you. So Alex, if you run a Lambda function every single second with, and let's say that you're handling 10 transactions per second, and you do that over a 24-hour period, you're probably going to pay more than if you just ran it in a container
Okay, so that's
for the same load.
that's
right?
a cost thing. So from
Yep.
a client's perspective, they don't feel any different, right? They still get
No.
the response in the same amount of time.
Right. Yeah.
Right.
Well, I
If
mean,
you
the
wrote
Lambda
it
function is
properly.
going to be a little slower. So, but like we're talking about a like minuscule difference. The customer's not going to notice that.
Okay, so it's a cost thing then, really.
Well, but what if the application was latency sensitive? Lambda's not going to be your friend, right? So you're going to run it in a container.
You mean because it takes a little bit longer to start up?
Right, because it's going to take extra milliseconds to start up, somewhere between, like, I think we've seen it go from 3 to 20 in some cases.
Milliseconds. Okay.
Milliseconds, right? Exactly.
No, it's not very
Yeah.
much. I guess, I guess it depends what you're trying to build. If you need to be hyper sensitive to latency.
Right. In other words, it depends on the workload. It always does.
Okay.
Because we could have a API that's connecting to Lambda, but then that Lambda is again connecting to probably 2 or 3 other Lambdas. So if you're spinning up everything, that time, startup time could add up to something big. So
Yeah, it can. I will say though, is that remember that Lambda operates the way Aurora serverless operates. If you've just hit the Lambda and it's been within like whatever time period or timeout, Amazon, without charging you, is actually still going to keep your runtime environment up for a period of time to keep it, in a sense, hot, right?
yeah.
So if that Lambda function is actually being accessed on a regular basis, let's say once every 5 minutes, then that Lambda container, the runtime environment, is always hot. So from a startup, like a cold startup perspective, you probably wouldn't actually see any latency because that runtime environment, Amazon's going to keep it up for a little bit of time just as a courtesy in case you decide to ask for another execution. So, the details here are in how you load and performance test and seeing how the different environments execute, right? Again, costing perspectives and performance perspectives are pretty much the two things that would distinguish whether you would go from one or the other. For all the other, and of course the maximum, times, right, as far as like the 15-minute execution time. But honestly, that could be orchestrated out. Those are really the only two distinctions that might drive you towards one and the other. But Alex and Arpan, you're right. The distinctions are razor thin, right? It really depends on your workload. But in general, it's true that Lambda over a 24-hour period with the same workload is going to cost you more versus running it, continuously on a container. So, but you'll also scale better. You will scale better on Lambda. Yeah. Okay. Good questions. Anybody else? Okay. This is continuing the exploration of the user topics and messages, kind of API calls. They're putting an ALB in front of it, which is what we saw before. And notice in this particular case, it's going to, multiple EC2 instances on the back end. I guess in this case, they're using the EC2 launch type. So this just basically is highlighting or showing traffic running through the load balancer and just hitting the relative microservice. If you are interested, there's a great workshop out there that I highly recommend that if you have your own free account that you take a run at. It's called the ECS workshop. Tons of fun. See, notice how the diagram on the page is showing you where it's going to talk on which box to talk to which microservice. So you get to set this up actually. And it's all like scripted and it kind of walks you through the whole process. It's a great learning experience if you've never touched ECS. Cool thing is about this workshop is it covers deploying microservices how to monitor them, different capacity providers, including blue-green deployments, stateful workloads, which is an important distinction because state on a clustering system with containers is slightly more difficult than it is with virtual machines. And the only reason that is because we're not familiar with it. We've been doing virtual machines for 20 years, right? And then you can get secrets. So if you haven't touched vaults or how to store credentials into an external vault system, this touches it. How to migrate workloads to ECS, service mesh, and then there's a new product called ECS Anywhere, which will literally allow you to run ECS in your data center. There's also a version called EKS Anywhere, which will allow you to run EKS in your data center. So this is a great little workshop, and for the low price of $19.95, no, I'm just kidding. You can get there's an EKS workshop as well. This one, by the way, is crazy dense. So I recommend that you do the ECS workshop first if you're really interested in learning about containers, because that's going to be an easier path. This EKS workshop, I know it deceives you because it's got these little things on the side that say beginner and intermediate and advanced. Guess what? If you click on beginner alone, there's like 20 workshops underneath here. Similar things, how to deploy Windows hosts, how to deploy stateful microservices using Amazon FSx. There is a treasure trove gold mine here. And by the way, this is going to cost you less than 50 cents to run all of these labs inside your account, as long as you don't leave anything running. If you walk away in the middle of one of these labs, you might end up paying $1 or $2, just so you're aware. But otherwise, this is a great way to get deeper hands-on experience with ECS and EKS if you're looking for it. Okay. By the way, these links will come to you in email within 24 to 48 hours. So you're going to have more access. So ECS and EKS workshops, drive this deeper. Here, by the way, the way this works is that, and this is the same as it is with Kubernetes, right? Is that when you say, I want to run 5 instances of the topics app, it's going to distribute 5 instances, as you saw me drawing with my little boxes earlier. If you ask for 10 instances of container B, it's going to distribute 10 containers. By the way, if one of them fails, or if a host fails, ECS and EKS both will redeploy your missing containers to the number you specified on the remaining hosts. And in ECS and EKS's case, if it's a managed node, it will actually restart the node. So it'll actually make sure that the node recovers, right? So if the host box fails that's running the containers, it will redeploy the containers and it will restart the nodes as needed. Both ECS and EKS will auto expand your virtual machines if you don't have enough capacity for the containers you've requested. You do have to set that up, but you can make it so that it auto expands your cluster if you don't have enough capacity to host all of your containers. So Kubernetes, the EKS service, but Kubernetes in particular, is actually cloud aware. So if you run Kubernetes on top of EC2 or even in EKS, it actually will talk to Amazon and help manage your cluster if you give it permission to do so. So Kubernetes is cloud enabled, cloud aware. So it will actually manage your cloud systems by itself. Again, permissions being a thing. EKS has the same kind of caveats. EKS also has a Fargate, which is a serverless mode, and it has an EC2 mode. It also has managed and unmanaged nodes. The only difference here really is that you are now creating a distinct system that has to be managed by you. So using kubectl, you're going to be using all of the standard tools that are available for Kubernetes. So just be aware that EKS is a slightly more complex beast than ECS. ECS is tightly integrated with Amazon. EKS is also integrated, but it's not tightly integrated. There's a lot of management you have to do with the Elastic Kubernetes service if you want the over and above features. That being said, here's the Kubernetes architecture. It is divided into a control plane, which is what manages the cluster. And here's the cool thing. When you run EKS, you do not have to manage the control plane. In other words, you're not responsible for making sure that the leader/master servers are up and running. You don't have to do any of that. With the data plane, as far as the worker nodes, that's where you get to choose whether you run EC2 instances or if you're running in serverless mode, where you're just running containers. So the data plane is where you actually add capacity. The control plane is invisibly handled by AWS for you. This is different than running your own Kubernetes servers on EC2, because if you roll them on EC2, you have to manage that control plane. And let me tell you, just going to mention this, etcd, which is the backend database for Kubernetes, is really fun to deal with when it works great. And when it goes awry, it goes horribly awry. So if you don't have experience dealing with that, I've lost weeks of my life back when I didn't know how to manage that. So just know that Kubernetes is an awesome product, but it's a little bit like Spider-Man. With great power comes great responsibility. So learn how to use your tools. Questions about Kubernetes, control plane, data plane? We could break down all this structure, but one thing is worth pointing out is that, see the container runtime engine? Notice that it doesn't say Docker. It's running a container runtime engine. So Docker conforms to the specifications for container runtimes. So Kubernetes just runs the container. It doesn't require Docker to run. Okay. Reminder that there is a serverless version. There are various limits to that version, which I will surface to you and post documentation for at our next lab. Now, so both ECS and EKS are highly scalable container services. ECS integrates with IAM. Kubernetes can also integrate with IAM if you set it up that way. EKS is going to give you all of these industry standard compatibilities that you want. ECS is not going to give you industry standard compatibility. Okay, so if you're wanting to mimic environments, like you want to run some kind of like containerization platform on Azure, Google, your on-premise, your laptop, and in Amazon, you're going to use Kubernetes to do that. In this case, you can use the AKS service. Sorry, the EKS service. All right, so here's a little comparison of compute, because I've talked about this several times as far as virtual machines, containers, and then Lambda. Now, notice that Amazon's kind of thrown that us on the side. They're like, but hold on, wait, Forrester. We've got not just containers, but we've got serverless containers, right? So that's the next thing. So this is really kind of the distinction. And I think our earlier conversation probably like made it a little bit more clear. But bottom line is that once you leave Lambda, there's more operational responsibility. That's true. You've got more operational responsibility in terms of scanning, footprints, and all this other stuff, because really Lambda just takes your code. You do not have really control over everything else, right? But if that's not really an issue for you, the operational responsibility, I would say that, those top two, Lambda and Fargate, are probably my go-to friends when it comes to running applications, right? They really are. If I don't want to deal with orchestrating workflows and blah, blah, blah in Lambda, and I don't want to deal with step functions, because sometimes that can be ornery, and I just want to run my application and I just want to like not worry about the 15-minute execution time, I'm just going to run it in Fargate, right? So otherwise, I try to avoid EC2 like the plague. And don't get me wrong, I run VirtualBox on my laptop. I love running virtual machines. I love running Arch, and I'm a Linux geek, so I absolutely enjoy it. But when it comes to hosting other people's applications, especially if I'm into a cloud provider, I'm just not going to run a virtual machine unless I absolutely have to. I'm just not going to do it, right? It's too much attack vector. It's too much operational management. It's too much patching. It's too much all this other stuff. And it's too fragile. And it's not really what most businesses are about. They really don't want to be good at running virtual machines. They don't even really want to be good at running containers. They just want to be good at running the application that solves customer problems, that generates revenue. And so this is why cloud, by the way, is so attractive, is because Amazon is trying to eat all of your operational headaches, because that's how they make money and win, but also it's how other companies make money and win, because if your company is good at running data centers and you're not in the data center business, I mean, in a way, we want to move away from that. Let's spend more time solving problems that solve our customers' problems instead of becoming good at things that are just kind of tertiary to that. Questions, comments, soliloquies, to be or not to be? That is the question. No? All right, let's do a quick knowledge check. Oh man, which of the following are characteristics of microservices? I have to say their definition was really slim, but there was only two, really, right? I know tightly integrated was definitely one of them. I know, just resist trying to choose D. Loosely coupled, autonomous and independent. Yeah, that's pretty good. By the way, so I framed loosely coupled as being like kind of like across the network using APIs. And I framed autonomous and independent as independently deployable and independently scalable. What was the third thing that I said made a microservice a microservice? And it didn't really have to do with technology. What was the third thing I said that made a microservice a microservice?
Independently scalable.
But that was part of the discussion I had though around autonomous and independent. So independently scalable, independently deployable, that was put together, right? That independence. So I've got APIs, which makes things loosely coupled. I've got that independence. What was the third thing that made a microservice compared to a monolith?
Choice of technologies, right? You can have each microservice be built by different teams using different technologies.
Yeah, but that's a characteristic of just having independent projects, right? When you run independent projects and they're communicating through APIs, you can use whatever technology you want. So that's just kind of a secondary effect, actually. That's a characteristic that comes from another primary characteristic. What is it that's not technology related that makes a microservice different from a monolith?
Different
Single
business.
responsibility.
Go ahead, Raj, what were you gonna say?
You can have different business logics.
Yes, hold on to that. Who was the other person talking?
Sufyan,
Sophie, go ahead. What were you gonna say?
single responsibility.
Yes, so both of you are correct. So you both hit it, right? Is that in a traditional monolith, that product represents every single business concern for that product line. So I'll give you an example. Netflix obviously had a DVD business and now they have a streaming business, right? So the Netflix product is comprised of about 30 microservices that make up that whole website that we go look at, including the streaming components. That's one product. If that were a monolith in a single Java application, all of those business concerns would be in one code base. But the other thing, other than APIs and other than being independently scalable and deployable, that makes a microservice is exactly what Raj and Sufyan just said, is that it actually solves one business concern. In other words, you'll have a microservice for billing. You'll have a microservice for like streaming, let's say mobile videos. You'll have a microservice for streaming desktop videos. You'll have a mobile service for account management. You'll have another mobile service that says, this is the top 10 trending at Netflix. You'll have another microservice that says, this is what we're going to do for the presentation layer for the website. Each of those is handling an independent business concern, and together they make up a product, right? So that's the other characteristic of a microservice that's different from a monolith, and that in a monolith, one code base or one application would have all of those business concerns for that product in that single application. With microservices, every single business concern is separate and run as a distinct service. Now you can get crazy with that, just so you know. You can get to nano services, which is a bad anti-pattern, where you're like, I'm going to do billing, but just for American Express. I'm going to do billing, but just for crypto, which might happen if you're at a large enough scale. But for most of us, one billing app to handle all the transactions is probably enough. Questions, comments?
I also hear that microservices, each one needs their own database. I don't know if that's something we cover here.
Yeah, it is a standard pattern that if let's say billing needs its own financial database. If anybody else wants to get to that database, they actually have to go through the microservice. They can't dock directly to the database, because that database and its associated microservice needs to remain independent from all the other services. So you're not going to allow applications to talk directly to your backend database. They actually have to use the same API to get data and manipulate data that the service is using. So what ends up happening, instead of having one big database with one big application, which is what we were doing with monoliths, you now get a bunch of smaller databases. What did I say? I said that distributed systems were hard, right? So it makes things a little bit more complicated, because now you're going to end, instead of one big data store, you're going to end up with about 5, 6, 7, 8, depending on what your concerns are. That does increase management overhead.
Exactly. And if you've got databases running for each service, but there's relationships between them, you can't, it becomes difficult to kind of, like, you can't do a join between multiple databases. It's difficult.
Exactly. You have to pull data from multiple sources, aggregate it, and then present it. So yeah, it's a challenge. That's like one of the costs of like switching to microservices, is that you get this great independence, but it does increase some complexity, especially data complexity. Cool. Good questions. All right, what are the following are characteristics of containers? Which of these are actually true for a process virtualization? Good. All right, see some answers coming in. First of all, we know it's not B. Hypervisors are for virtual machines. So we know that's not relevant for containers per se. Although, remember, containers still need an operating system to run. So you might be running on top of a virtual machine, but that's not really what a container requires. They're definitely not automatic. So your answers are apropos. A and D, right? Because while container deployment and all that stuff can be automated, you know, containers themselves aren't just like magically automatic, right? Good. Portable, scalable, repeatable. Because one thing you know about containers also is that when you want to change a container, you publish a new version of container using the same process with some modifications that you used for the previous container. So containers images, as they're deployed, are immutable. You deploy a new version of a container when you want a new version of the container to run. So you don't change running containers like you do running virtual machines. You actually redeploy a new version of your code. You do not change an existing runtime out in production. That's called immutable infrastructure. And that's actually been backported to virtual machines as well. So you're seeing that more and more. The only exception that people aren't using that for is with databases, because unless you can just rip the drive off and have data consistency, restoring like a 10, 20, 30 terabyte database is not a trivial thing. So immutable infrastructure, if you want to look that up, is something that's becoming more and more prevalent in the industry, not just for containers where it's native, but also more for virtual machines in a cloud environment. Containers in Amazon ECS are logically organized in what kind of grouping? What are they grouped as? Notice this says ECS, by the way. Because if it was EKS, just to say this, pods would be the right answer. Because containers are deployed in Kubernetes via a pod. But that's not the answer for ECS. And it actually technically isn't the answer for EKS either. Right? And it's definitely not S3 because that's a storage system. And EBS volumes are hard drives, so that doesn't sound right. So the answer is it's just a cluster, right? Kubernetes, ECS and EKS are really just container clusters. It's no different than Elasticsearch, which makes a database cluster. It's no different than Oracle RAC, which is a RDBMS cluster, right? It's just a collection of systems that have one purpose. In a database cluster, the purpose is to host data. In a container cluster, like ECS and EKS, it's just to host containers. So a cluster is actually technically the right answer. Pods would be the right answer if it said the base unit of deployment for containers in Kubernetes is what? And it would be pods. Pods are the base unit of deployment in Kubernetes. Containers go inside of pods. And so Kubernetes deploys pods that have containers inside of them.
So there's
Okay.
no ECS.
Say again?
There are no pods in ECS. There's some kind of other logical unit.
Actually, the base unit in ECS is just a container. The reason for that, by the way, is that Kubernetes can actually deploy, when you deploy an application, can deploy more than one container at a time.
More
Like
than
as a grouping.
more than one container in a pod if they're related. So in
Right.
EC, that's not the case.
No, you deploy groups of containers at a time, like container A, container B, container C. You don't deploy them like as a grouping. That doesn't mean you can't deploy multiple containers at the same time, but they're not deployed as a group, which is what a pod is.
Okay.
And the reason for that, Alex, is that even in pods for Kubernetes, you typically only deploy one application container, but you could have operational security. You could have other like ancillary sidecar containers in that pod whose job it is to either gather information or support the application container. So typically, even in a pod, you only have one application container, but you might have other ancillary concerned containers in there, such as security, like catching logs, looking for, malicious traffic. You could put containers into the pod that do those functions. That's a whole Kubernetes class, actually. Oh, well, okay, I just answered that for us. Sorry. Which of the following are components of Kubernetes architecture? Well, we got that. 2 planes, right? The data plane and the control plane. Where do containers run in ECS, EKS? Do they run in the data plane or do they run in the control plane? If I'm running containers, that's right. The data plane, right? The data plane is where the data lives. In this case, it's containers. The control plane is where the supervisors live, right? So just keep that true. And that's true for ECS as well. Okay. Why would you select to deploy your containers to Fargate over EC2? What are some options here? C, let's see. Is that right? Take control of your infrastructure to avoid manual infrastructure updates, to optimize price for a large load, to manage your own patches and updates. So I think the only reason that C might not be the answer is that Fargate cannot handle as large of a load as EC2, but I would argue that that's actually more cost efficient. So maybe C could be the right answer. I think what they're targeting though is they're trying to avoid manual infrastructure updates so that you don't have to manage your EC2 instances. But I feel like I could argue that B and C are true because that is a good reason to use Fargate is frankly, it's cheaper. And you can actually get pretty large loads. As a matter of fact, let's go take a quick look at that since this has come up several times. Oh, I guess I've looked this up before, haven't I? Nope, that's old. So that's not going to help because that's back on 2019. Let's see here. Fargate considerations. Okay, so underlying isolation, match Fargates, daemon sets aren't supported. Yeah, that's cool. GPUs aren't available. We know that as well. Vertical pod autoscalers. Give me just 1 second. Can't deploy it to local zones, AWS outposts, or wavelength. Okay, cool. But where are the limits? Not listed here. That's interesting. Huh. I might have to dig that up. See, this is what I thought was going to happen is that it doesn't actually say very clearly what the limits are. Amazon doesn't like advertising their weaknesses. So I'm going to dig this up, what the actual limits are for Fargate when we do our next lab, and I'm going to make sure everybody has it so you know what the limitations are. Because this happens every single time. It's hard to find. I usually have to go find somebody's blog post, which usually links to the existing documentation. I'm gonna figure out what it is in this Q4 2021. Okay, so that's the end of module 9. Does anyone have any questions? Okay, let's talk about networking. All right, so let's talk about this next set here. So this is networking 2. This is the sequel, right? Sequels are not always better than the originals, but hopefully this one is. Okay, so check in. How many VPCs does your organization use? Is that something that is advertised at Travelers? Do you know how many VPCs your organization uses? I'd be shocked if you all knew.
Feel like it's great. I feel like I've done 2 on one project.
Yes, I suspect it's greater than 100, right?
Yeah,
Yeah.
but we don't get, at least I don't know of any large scale numbers shared.
Huh. That would be some interesting characteristics to publish, right? If it was like, hey, this is like how much we're using in general. Sorry, my phone started ringing and I'm like, okay, how do I turn this off? But hopefully you all can't hear it because my headphones are great in noise cancellation. Can anybody hear my
Yeah.
phone ringing?
No, I did not.
Sweet.
I actually keep checking my mic or my headphones in the morning when I see you're moving, like, well, I should be hearing sound.
Yeah, they were remarkably good. Okay, so moving past the silly VPC question, let's talk about this. So, all right, so security policy states that we need to have isolated infrastructure. So we're going to start out with a smaller number of networks, but it's going to grow. Many of these independent VPCs will need to communicate with each other. What are the options for putting these two together? What if we need to connect hundreds of networks? And so in addition, how do we get our data center access and how do we access public services like S3 and all the public APIs if all I have is private subnets, right? How do I do that? Because I don't want to run my traffic across the internet because it's not really ideal for our security policy. So security, communication between services. What if I want to set up a hybrid network? How do I manage traffic for all these rapidly expanding? And how do I use DNS resolution? How does this, does Amazon have a service for this, right? So these are the things we're going to talk about. Now, notice here, we've added a couple extra things to our diagram. I've now got virtual private gateways, which is used for VPN. I've got VPC endpoints, which is a way to talk to public services from a private subnet. And then I've got Route 53 here, which is Amazon's DNS service, kind of like, you know, on semi-steroids or whatever appropriate reference I can make, right? Here, by the way, is a little bit of a deeper dive between a customer gateway device. So you can see that this on-premise data center on the left-hand side, it has 3 additional connections from an on-premise data center, and it's going into this virtual private gateway. Now, here's the catch to this, right? Is you see that direct connect gateway and that direct connect location at the bottom of the graphic? That's actually a physical cable. So you can actually run a cable from your data center over to Amazon's data centers and get connected to Amazon's high-speed backbone through a 1, a 10, or a 100 gigabit connection. Now, you'll never really know where their data center is because they require you to connect to a partner who in turn will connect you over to Amazon. But just note that you can actually get a physical wire between you and Amazon. Obviously, that's not necessarily more secure because it's not encrypted by default like it is with a VPN channel, but note that it is dedicated. So if you're worried about internet weather, you know, when the internet slows down because everybody at 10 p.m. starts looking at Netflix or Disney Plus or God, whoever else we have now, and your VPN connection starts choking out, well, that's why. So if you need consistent bandwidth and you want it cheaper, because honestly, the price per gigabyte is cheaper for direct connect than it is for across the VPN gateways, then the direct connect is going to be your friend.
I'm assuming that's quite pricey.
It's been so long since I've actually been involved in the price negotiation for direct connect that I actually can't tell you. But like a 1 gigabit connection was only like $1,500 a month back in 2017, 2018. So
You have, the company would pay for putting that line down as well.
oh yeah, oh yeah, yeah. I didn't do that. Although I do know somebody who has a direct connection to their house, and I'm like,
To their house.
wow, yeah, they are hardcore. They have all the certifications. Anyway, So that being said, let's talk about some solutions for connecting VPCs, endpointing them, so going from public to private, and then hybridizing networking and using DNS. How can my services talk to each other without routing through the public internet? That's a great question. So without a VPC endpoint, what ends up happening is that if you're trying to talk to DynamoDB and you're on an EC2 instance, this is literally the traffic flow. Notice this private subnet has to go through a NAT gateway to the internet gateway, across the internet to DynamoDB. Now you might be like, well, hold on, Michael, aren't these located in the same data center? That's the official technical term. Kinda, not really. Because, right, I mean, Amazon's got stuff scattered all over the place. So it's in the same region, don't get me wrong. But these regional services operate kind of in their own regional data centers. They're not inside like the data centers that we use, the AZs per se. Now, that being said, let's say that you're like, okay, well, that's not acceptable. Is there any way I can just talk directly to DynamoDB through some kind of private connection? And this is where a VPC endpoint comes into play. Think of this, by the way, as a NIC. Some of you are like, Michael, you just keep talking about these network cards. Think of this as a NIC that has private access to a public API. And by the way, there's two types. There's interface endpoints and gateway endpoints. They're virtual devices, basically. They're horizontally scaled and redundant. You don't have to worry about them failing. And they basically permit communication from a private subnet into a public API. That's what they do. They have their own permission sets, and this, by the way, I think you set resource-based policies on these as well, if I remember correctly.
Doesn't this kind of setup look like a really bad latency problem?
Say more about that.
You have a database outside of the VPC and an application running in an EC2 instance inside a private subnet in a VPC. The communications here are, I mean, it's nice on a diagram, but would you really ever do something like that? Aren't your databases supposed to be close to you? Or this is just an example. Like, it doesn't have to be a database, right? It could be any public IP.
No. I mean, we're only talking about what, 3 milliseconds of latency? This is over Amazon's high-speed backbone, Alex. This is super fast.
I always thought you're supposed to put your database as close as possible to your application.
And that might be true, but if you're using a managed database, this is probably as close as you can get, right? And so that's the thing, is that this is not as close as this is, right? So, I mean, your concern is totally valid, but the proof is in the pudding. What's the latency difference? And you can't run DynamoDB inside the VPC, so that's your only option, really. But just to say this, I mean, the latency is usually 3 milliseconds for standard DynamoDB. If you put DAX in front of it, you get down to microseconds.
Oh,
So-
okay. Then so then DynamoDB is still technically in Amazon, right? This is not like because I think the whole internet thing threw me off. Like,
Oh, yeah. No, this is still hosted in Amazon's data center. This one's over the high-speed backbone. This one is running across the internet.
right, so it's leaving Amazon, going through the internet and coming back to Amazon.
Yeah, and to be clear though, it's not going too far into the internet. It's probably making one hop, still on Amazon's routers, but part of their public infrastructure, not their private infrastructure, and then hopping into their private infrastructure. So it's probably not even going too far into the internet, because that DynamoDB database, since it's regionally located, is probably very near to those data centers. So it might be going 1 or 2 hops out into the internet, and that's it. Not something to be too concerned about. This is probably, obviously not having tested this in a long time. This, I don't even remember what the number was, but I think it was like 10 or 20 seconds of latency. This one was far less than 5.
Because in our last lab, we had this EC2 instance in the private subnet, and we stuck a RDS, doesn't matter, inside that same private subnet. Right. So
Right.
Yeah. So I'm just not sure why you'd ever do this, but okay, let's just move on.
Yeah, well, this would be the preferred method to access a managed service. So RDS is a platform as a service and not a software as a service. So it still requires EC2 virtual machines to function. And since it's EC2 based, you can put those inside of a VPC. But if you're using a managed service,
okay,
you're not
that's
going to
the
do that.
difference. That's the
Yeah.
difference. Okay.
Yeah. So yeah. Yeah, it's funny because RDS is sold as like a hot, managed database system, but it's more of a platform as a service. It's not a fully managed SaaS like the DynamoDB is. Okay, so I mentioned before, there's two types of VPC endpoints. There's the gateway endpoint, the interface endpoint, and the new gateway load balancer endpoint. Gateway endpoints really are only used for S3 and DynamoDB because they've been around for quite a while. The interface endpoints pretty much govern all of the other services, right? And the difference here is that an interface endpoint basically is an elastic network interface. It has a private IP address from the IP range in your subnet. So it's going to pull an IP address from the private range in your subnet to run an interface endpoint, the one in the middle. The gateway load balancer endpoint is relatively new. It's also going to pull a private IP address from the range, but it's basically only used for gateway load balancers only. That's it. It's used to distribute traffic across a virtual security appliance, scaling them up, scaling them down. So a gateway load balancer endpoint is only going to be used when you launch a gateway load balancer. Otherwise, the other two are used so that you can connect to public services over a private interface. That's what it's really used for. Reminder, this shows up sometimes on the exam, by the way. Gateway endpoints are older, and so they only support two services, S3 and DynamoDB. Every other service is going to be under an interface endpoint. Here, by the way, you'll notice the different endpoints kind of listed here. So for example, that's an area gateway at the top, but like a gateway endpoint here for DynamoDB, a gateway endpoint for S3. Notice that unlike going to like a specific IP address, which is what the interface endpoints do, the gateway endpoints show up inside your routing table and they have this unique ID that delineates where these things are. So nobody needs to go out to the internet to get over to these services, right? That didn't happen. What ends up happening is they can just go straight in now because the route table contains the routing in question. You can do the same thing with the interface endpoints. The difference is that you're probably going to point to an IP address, but I think you can grab the ID as well for the interface endpoints. So let's take a look at those. So these are gateway endpoints. Here's the interface endpoint. Notice here that you can actually put an entry in your route table if you want to, or, right, you can connect to the service directly just by using an IP address. So notice that there's a NIC right here that has an IP address, 0.6. So you can just connect to that directly if you want to get to Systems Manager, right? Now notice that since it's already part of the local routing table, it's just going to go there, right, if it's looking for it by default. So when you do a DNS lookup, by the way, using Amazon's DNS resolvers, and you activate a network interface endpoint, if you look for the Systems Manager API, instead of going over the internet, it's going to go by default through the private interface. So all of that is orchestrated for you. So you don't actually need to manipulate any route tables or do anything unless you really want more control over the network flow. Literally Amazon, once you turn the network interface on, the interface endpoint on, it will do the modifications for you so that your traffic goes over that interface instead of having to go across the internet. NICs for everyone. Here, by the way, is a solution where they are doing like a private link, by the way, is a way of just sticking NICs inside of your networks, right? Notice here that they are putting down an interface endpoint powered by private link, which is what they call this whole technology. And it's pointing to a network load balancer, which points to an application. So it doesn't necessarily just have to be pure AWS services. You can point it towards a load balancer, which will point it towards any box that you have behind it, right? So you can actually connect to services hosted by other partners and other accounts and other VPCs with a shared application. A lot of this is, by the way, is available in the shared marketplace. Let's see. Oh, doing it this way, by the way, solves a very important problem, is that everybody's using the same IP addresses. 10.192.172 dots, right? If you use an interface endpoint, this allows you to connect to other networks that actually might have the exact same network range, which is usually impossible to do. So just know that this is also an option if you feel like you have overlapping ranges either internally or with another customer or a vendor, as an example. Okay. Here's accessing S3 from on-premise. So in this particular case, you've got an on-premise application. You've either got some kind of connectivity, either VPN or direct connect, and you are actually talking to an interface endpoint, which then goes over to S3. Otherwise, what would have to happen is you'd have to route across the internet to get to S3. Right, you'd have to talk through the public interface. Okay. All right, so that was all about VPC endpoints. Let's talk about VPC peering. How can VPCs talk to each other even if they belong to different AWS accounts? Okay, so again, we kind of touched on this a little bit already, but you can actually connect VPCs together as long as their network ranges don't overlap. So kind of a case in point here, notice that this is different than this, and these are all /16s, right? So different. So you can peer them together. By the way, just because A is connected to B and C is connected to B doesn't mean that A and C can talk to each other. These guys cannot talk to each other. There's no transitive peering, right? Notice it says it over here. There's no transitive peering relationships inside these systems. So if you want to connect to a third party, you have to directly connect to that third party. You can't route through somebody else's VPC to get there. Now, VPC peering connections usually will involve a change in the routing table, which requires you to list, if you're looking for the 2 network, go over here and talk to this exchange. If you're looking for the 1 network, go over here and talk to this exchange. Right? So they're flipped. If you're looking for the opposite network, go here. If you're looking for the opposite network, go here, right? And this PCX1 that's defined is like the VPC peering exchange. This is given to you when you initiate a VPC peering request. So there is a limit, by the way, I want to say it's like 400 of active and pending VPC peering connections you can have per VPC. By the way, this gets really ugly when you have to connect every other VPC to every other VPC. So yeah. So then what's the answer? Well, we'll get to that in just a second. But this is the kind of the old way of doing it. It's still really valid if you just want a simple straight up connection, right? Notice that a lot of people do what's called a shared services VPC right here in the center, and all the other VPCs might consume its central shared services. This could be true, by the way, also of the VPN connection down here, as well as another region. Because you can peer, by the way, across regions. You do not have to peer just in the same region. You could peer Virginia to a VPC in Tokyo. There's also a full mesh peering where every VPC is paired to everybody else. So just something to keep in mind is that you can actually put all these together. But remember, no transitive peering, and this can get pretty cumbersome if you're trying to do a full mesh. You're only capped at like 500 connections per VPC. I know this sounds like a lot, but it's not for most enterprises. Now, that being said, there's a second solution called Transit Gateway, which will allow you to also connect VPCs together the world over using more routable technology. And it will also help you manage your VPN connections and your wire connections with Direct Connect. So this will allow you to not only route all of your external connections to whatever VPCs you want to, but it'll also allow you to connect VPCs together, as you can see up here. Right? So you can route on both sides, both on the internal end and on the external end. So yeah. like, for example, if you're going to take 6 VPCs and you're going to peer them up, that's about 15 independent connections, peering connections that you have to set up and manage. And so that's just 6 VPCs. Most people don't have 6 VPCs. They've got hundreds of VPCs. So just know that you're going to want to use Transit Gateway if you're doing anything above, I would say 20 VPCs, because I think 20 VPCs ends up with like 80 independent connections, if I remember correctly. My math is probably off, but regardless, it's a lot. So Transit Gateway is what you go for now, because it's been around for 1 or 2 years now. Transit Gateway is what you go for now when you want to peer both VPCs and control the routing of your VPN and your direct connect connections. So this is without, for example, a Transit Gateway. I know that, like, I didn't make that clear earlier. This is without a Transit Gateway. This is with a Transit Gateway. So instead of having to connect all this stuff together with a Transit Gateway, you just centralize on one routable center, and it routes across to all the systems that you need, right? So now you can have multiple VPN connections, but they're terminating on the Transit Gateway, and you have direct connect connections, and they're terminating on the Transit Gateway, instead of you having 50 route tables on the external side and 500 peering connections on the internal side. Instead, you got this. Hey, I want all these guys to talk to each other. I want this specific subnet and this VPC to be able to talk with this specific subnet and this specific VPC. And you manage it all from one place. A lot easier. This, by the way, also supports multicast, which is something that Amazon traditionally has not done. So the 224 IPv4 addresses. So if you need to multicast packets across the network, you can. Other features, you can give it to 5,000 VPCs and a single Transit Gateway. By the way, you can hook Transit Gateways together. So if you want more than 5,000 VPCs, you can figure that out too. It will do inter and like broad regional kind of peering and connections, but it really acts as a hub for all traffic to flow through. Raj, sorry, was that for us? No? Or maybe she said. All right. The components of Transit Gateway are basically your route tables, the VPCs themselves, the VPN connection. In other words, the connections that you're trying to hook them in. What happens is that all those VPC route tables and all those like different pieces are folded into the Transit Gateway and set up inside the route tables. And so what ends up happening is that you figure out how to attach the various connections, like the VPCs and the VPNs and the Transit Gateways all together, right? And it works across AWS accounts. So you attach the following: you attach your VPCs, you attach your VPNs, you attach your direct connect gateways. If you have another Transit Gateway, you can set that up as a peer, and then you just basically control the flow of how these different elements talk to each other. Now, since a Transit Gateway does exist inside of a particular region, attachments usually have to be in that same region. So if you're peering with another VPC, you're typically going to attach to another Transit Gateway in that region. So, and they will support static and dynamic routing. Here's full connectivity where all VPCs can talk to all VPN connections and direct connects to all other VPCs. So it acts as a central hub, right? That's really what it's for. This is full connectivity, which is bidirectional. This is partial connectivity, right? I guess the ones on the left are blocked, right? Here's some isolation, right? Where basically everybody can talk to the VPN, but they can't really talk to each other. There's a lot of scenarios with Transit Gateway that you can set up, right? Isolating with partial connectivity from each other, full connectivity with each other, isolated so they can't talk to each other, but they've got access from a VPN. You can secure this as you see fit, secure the flow of traffic as you see fit. All right, so that's VPC endpoints, which allows you to go from private to a service. That's VPC peering, which allows you to directly connect VPCs together. And then the transit gateway, which acts as a central routing hub for all of your connections within a region, but you can also connect with another transit gateway in another region. So you can actually make it inter-region at that point in time. So now we're going to talk about hybrid networking a little bit, including things like site-to-site VPN, which basically just offers 2 VPN tunnels between a virtual gateway. One is on the AWS side, one is on the customer side. And so this just allows you to use VPN, which most people are familiar with because VPN has been around for a long time. Here, by the way, there are 3 different connection methods to connect your VPN connection over to AWS. You can actually connect to a virtual gateway. You can connect to an EC2 instance, which is a completely unmanaged solution. So you're connecting to a VPN on an EC2 instance, or you can actually connect to a transit gateway, which is how obviously most people are preferring it now, right? I love that they threw in option 2 EC2 instance. I haven't run OpenVPN in a while, but we definitely have done it in the past to make our own VPN connections into networks instead of using Amazon's. There's pros and cons for that. Now this is VPN running over the internet, right? Direct Connect obviously is a little different, but same challenges. You can go to a virtual private gateway, or you can go into a transit gateway. Here, there's a fiber link directly into your VPC, easy to set up and easy to do. Here's the Direct Connect setup. Notice it says 100 gigabit to now sub 1 gigabit links. Sorry, that is true actually. You can take a 1 gigabit link and fractionate it. You can, if you only want 384 kilobytes or something weird. God, that's old. If you only want a couple megs or something, you can do that with a partner, but typically people pay for 110 or 100. And then here, by the way, is Direct Connect VPC connection options. Same thing exists. You can either go to a virtual private gateway, you can go to a Direct Connect gateway, or you can go to a transit gateway. It's 3 options. The only difference here is that there's no roll your own option. So you can actually run from a Direct Connect router into a virtual private gateway, which is the same as what you use for VPN. The Direct Connect gateway is something special that exists only for Direct Connect. That's the middle option right there. And the one on the right is the one connecting to a transit gateway. So same, at least 2 primary options. You can connect to a virtual private gateway or a transit gateway, but Direct Connect does have its own gateway that you can use that is not used for anything else. Okay. Questions about either VPN or Direct Connect as it relates to either a gateway, a virtual private gateway, or to a transit gateway? Okay. Let's talk about Route 53. So this is DNS Plus. When Amazon started getting into this, by the way, it was amazing how the other public DNS providers like Dyn and whatnot started getting real serious about their offering because Amazon started pushing on them, right? It acts as an official registrar if you want to, and it can route requests based on a number of policies, but it does what DNS does. It resolves names to IP addresses. Now, you can actually host a publicly hosted zone or a privately hosted zone. A hosted zone, by the way, is just a collection of records, right? And public hosted zones are basically used when you want to route across the internet. And private hosted zones are when you want to route or resolve inside of a VPC. So one is public for internet consumption, one is private just for internal only use and consumption. Now, that's not really, this is no different than any other DNS server. So that's not really where this shines. Where this really shines is in routing policies. So DNS in Amazon is really cool because DNS is not a great failover mechanism, but the way Amazon does it, it's actually pretty good. You can have simple policies that say, hey, if I go to www.amazon.com, go here, right? In this case, it's actually 2 locations. So there seems to be some kind of round robin or multi-value answer here. Failover routing is when you want to route to someone, but if a data center goes down, DNS, I want you to stop sending people to that data center. In other words, there's a DNS entry, a single DNS entry, and it points to 2 places, US East 1 on the top, US West 2 on the bottom. If US West 2 goes down, I want you to remove that entry and stop sending traffic to US West 2. This is a health check, by the way, that you can set up. It could be a CloudWatch alarm. It could be a specific resource. It could be the status of other health checks, so you can chain health checks together. This is failover routing. You can also do what's called geolocation routing. In other words, if the user's in France, then go to Germany, right? If the user's in South America, in Brazil, then go to Sao Paulo, right? So there's a way here for you to control based on geolocation awareness about where the user is coming from and route them to an appropriate place. So you can use this to control where users go. Geoproximity doesn't actually go across geographic boundaries. It says who's closer. Like you could be in northern France and be closer to Germany, but you could be in southwestern France and maybe be closer to Spain, right? Both in France. So just something to note is that geoproximity routing says which data center is the person physically closer to. Now, this does not say who's the fastest. Because, for example, let's say that Spain is overloaded, but the user's closer to Spain, but Germany's latency is way lower, so Germany is faster. Well, that's where you would use latency-based routing. So in our example here, notice that EU West 2 is faster at 76 milliseconds than US East 1, which is 137 seconds of latency. So different than geo proximity, which says who's closer, this one says who's fastest. DNS, I want you to route me to who's fastest, not who's closer. And then multi-value answer is like almost like a little bit of like round robin. It says, look, I've got 15 servers attached to this DNS name. Just go to any one of them. If one of them is unhealthy, by the way, it's going to take it out of service. By the way, the reason this is okay, but it's not a load balancer, this is not global load balancing, by the way. The reason is that people, clients, servers will cache these DNS resolutions, and you can't control that. Don't get me wrong, you can set a time to live on your DNS server, but you can't control how someone keeps your data when they pull it down. In other words, let's say I go in and Amazon.com resolves to 10.1.1.3. And at first it's working, but then it becomes unhealthy. But my desktop, even though the time to live says, hey, I need you to check this every 60 seconds and get a new value. What if my desktop was set to keep it for 24 hours? When I go to Amazon.com, that website's going to be down for me because my client, me, I kept that DNS entry. This is why DNS is not a great mechanism for failover. It's not a great mechanism for load balance. It doesn't replace the load balancer because clients can hold on to those numbers. Even though we tell them not to, they still do. Okay. So this is still very useful for latency-based routing, geoproximity, geolocation, and failover routing, and even for multi-value. But just know that it's not really a substitute for like a global load balancer, like a global accelerator. Okay. Other things to know. There's also weighted routing. This is fun, actually. This is, by the way, how canary deployments happen, where you're like, hey, I'm going to shift all our traffic to 5%, or A/B testing, or they also call it weighted testing, or blue-green deployments. This is how this happens, is that you're either doing 100% or a percentage of traffic. And in this case, 90% is going to US East 1 and 10% is going to US West 2. And maybe you've rolled out a new version in US West 2, and you're like, I just want to roll 10% of traffic there and see how it does. And if it does really well, maybe you'll roll 100% of the traffic over to US West 2. So the weighted routing is a great adjunct to multi-value, to latency-based, to geoproximity, geolocation, and failover routing. We were looking at simple routing before, just so you know. Okay. Rah. All right, let's talk about a resolver for hybrid clouds. So the last thing you need to know is that every time you create a subnet, Amazon takes 5 IP addresses, and one of those IP addresses off of your subnet is the DNS resolver. So this allows you to resolve IP addresses for machines that are on your subnet inside of your VPC or another peered VPC, right? And so like in this particular case, when you create a VPC, you want your DNS queries to resolve seamlessly between your environments. Amazon sticks a resolver inside your availability zones, inside your subnets and your VPCs, so that you can find your local systems. It will, by the way, perform recursive lookups for public services as well. So just know that if this is typically, people don't roll their own DNS servers for their containers and for their virtual machines inside AWS. They just use the AWS resolvers. If you need control over this, you're gonna have to roll your own DNS server, just FYI. That's what really this is showing you. Let's see, the dotted arrow here basically represents a request from an on-premise client. So let me actually highlight this because that would probably be useful. I was like, what is this diagram actually showing us? Client is actually resolving Amazon.com, or maybe it's looking for an EC2 box. Maybe it's looking for an EC2 box. So what happens is that the DNS resolver can be set to talk to Amazon's resolver, which can then resolve to an internal endpoint. In this case, an EC2 instance. So just know that you can actually configure forwarding rules in your internal DNS servers because you have a private connection to AWS to talk to Amazon's internal resolver endpoints. So you can link your DNS servers together from your on-premise environment into your AWS environment. That's really what this is telling us. All right, questions? Hello, hello, hello. Okay. Well, let's talk about this last little piece because this is going to be a knowledge check. Okay, what is a network connection to a transit gateway called? What was it shown in the diagram? What was it referred to? No? Okay. So in this case, it was called an attachment. Okay. What are the components of an AWS site-to-site VPN connection? What were the two things that were needed on the customer side and the AWS side to define those connections? C and E, virtual private gateway and a gateway endpoint. Close. So C is definitely it. A customer gateway device is the other thing. So close, right? So you need a customer thing, a customer gateway device, and you need a virtual private endpoint to really manage your site-to-site VPN connections. Okay. What is true of VPC peering connections? Are the connections one-to-many or one-to-one? Can connections span accounts? Do they require a transit gateway or are they transitive? All right, so see that connections are one-to-one and connections can span accounts, and that's accurate, actually. They are indeed one-to-one and they can span accounts. You do not need to use a transit gateway. You could use VPC peering. That's what the other option is. They are definitely not transitive and they are definitely not one-to-many. Okay. How can an application running in a VPC access S3 without internet access? So someone give me an option. And this one they are haggling over because you probably know that it's some kind of endpoint, but which of the endpoints is it that only handles S3 and DynamoDB? Oh, by the way, you can actually use the other one to connect to S3 as well, by the way. I didn't mention that. I made it sound like it could only handle other services. So in this particular case, it's both of the endpoints can talk to S3, right? So a gateway endpoint or an interface endpoint can both talk to S3. Gateway endpoints, though, can only talk to S3 or DynamoDB. The other interface endpoint type can actually talk to all the services. Sorry, I probably de-emphasized that. Good. Okay, that's module 10. I know this is going to sound weird, but we actually have one more module to do before we get to our lab. Okay, let's get into it. Edge services. All right. Trying to get us to labs. I really am. Okay, so here's our check-in. What percentage of your workloads require ultra low latency to devices and end users? These questions, they crack me up. While you are all pondering the mysteries of that deep universe, I'm actually going to go over here and start lab 5. Get a little pre-warmed. Okay, just making sure. Excellent. Does anyone have any applications or workloads that require ultra low latency to devices and users? Do any of you have super latency sensitive applications? Yeah, I mean, unless you're dealing with like real-time trading or kind of emergency services, I don't really know of any from other insurance companies that I've dealt with, but I don't know your full product portfolio. Okay, so here's our stakeholder feedback. We have 1,100 customer care pros across the globe, and they access project files on a daily basis. Right now, all the project files are fulfilled from a data center in California. However, the further they are, the more latency they have to serve their requests. We wanted to explore a way to lower the latency to end users. We also want to build some protection against distributed denial of service attacks. So we're wanting to increase global network security and decrease latency for our resource requests. So this is where the edge services come in. This is what we're going to kind of dip our toe in. So Route 53, we already talked about. CloudFront, we've kind of talked about. We haven't really talked about Global Accelerator. And then here we have Shield Standard and web application firewalls. And then of course, if we wanted to run Amazon hardware in our data centers, then we can always use AWS Outposts in order to do that. But notice this is going from ISP into DNS into some kind of routing, some kind of content distribution or load balancing. And then we've got some protection mechanisms here that could lead to an application. In this case, Outpost is listed here for some reason. So there's a couple of options for how we could attend to these particular stories right here. How do I improve the latency of my internet applications? How do I secure my data center? What if my application needs fast regional failover and a static IP address? What are my options? How can I use AWS services to run workloads in my own data center? And how can I protect public-facing applications? This actually is going to be a pretty quick module. So here's some edge fundamentals, right? First of all, defining the edge of AWS is really interesting because AWS wavelength is for 5G providers who want to get like cellular 5G like at their edge locations. Outpost is for running Amazon hardware inside your data center. And then we've already talked about edge locations and local zones as being ways in which you can either cache content at an edge location or run a full millisecond sensitive application into your local zone. And that's not including the core stuff around regions and whatnot. Oh yeah, actually that's a good request. Actually, you know what? I'm sorry, I was remiss and someone just reminded me. It's actually 10:49. We should take a break actually, shouldn't we? Let's come back in 16 minutes. So let's come back at 11:05 and let's resume this little run. So thank you for saying something. Yeah, let's take a break. What am I thinking? It's 10:49. So let's come back at 11:05. I'll put up a timer. Welcome back, everybody. Okay. Okay, so we were talking about edge services before I interrupted us to have a break. Thank you again. Thank you for reminding me. Sorry, I was barreling along. So we talked about how the edge has many different kind of physical locations or possibilities for AWS outside of just the core networking. That includes the edge locations as mentioned, local zones for hosting latency sensitive applications closer to your users, wavelength, which is for cellular usage, and then outpost, which is obviously just running inside your data center. Now the edge locations are near every major ISP. So, well, that's weird. Can everybody see my screen?
Yes, we can see.
Oh, was there a delay? Sorry about that.
But yeah, not right away. Now we can.
Okay. Sorry, that's what I was talking about before. So we haven't hopefully missed any slides. Here are the edge locations. The edge locations are basically caching locations that are located near every major ISP. So if there's a major internet service provider on the continent, that's typically where they're going to have caching locations. Now, notice that there are those locations right now. This is actually just regional locations. If we actually add the edge locations, and notice that it's like acts like they're kind of scattered all over. There's actually only like 400 or 500 of them. I know that make that sound like that's a small number. It's a lot actually. So with the edge location, we've seen this story before, is that this is how customers in remote locations can get a cached copy of your website, your videos, your images, even APIs, depending on what the nature of the get is, right? So that we can actually make it less latent, so faster for customers. So this way they can actually use a cached copy instead of having to go all the way back to the origin if the cached copy is fresh and not stale. So this is where we talk about content delivery networks like CloudFront, where all these caching locations that are scattered all over, and actually even this is not accurate. There's some locations missing here. I could tell that just by looking at it. 230 points of presence. I think it's closer to 400 now, actually. I could be misquoting, but we actually just had a guy who was in class who actually is installing them for Amazon. And he was like, we're on target for 400. So maybe that's not been announced yet. So without a content delivery network, without edge caching, what happens is that every time a user all over the world needs to get content, they have to go back to the source. But if they're in Tokyo and you're in Virginia, that's a problem. If they're in Melbourne and you're in Germany, that's a problem because it's a long path to go down. So without edge caching, you kind of keep going back to the origin every single time. With edge caching, what happens is that AWS automatically copies forward the content that's being requested to the caching server without you having to do anything based on where the user is located. As long as you set up your origin and all your policies correctly, it handles it for you automatically. So you get increased lower latency, increased reliability and availability, because now you've got your objects, copies of your objects being held all over the world. So CloudFront is a cloud content delivery network. It does integrate with all the security tools. It can be static or dynamic content, Because you can't actually run dynamic content over the backbone. I will say that static content is probably a better use case. But I mean, to make this clear, you are running over Amazon's backbone for this. So even dynamic content is going to run faster. But it won't get cached or reused. So it's really just data transfer charges at that point in time. The way caching works is that you are going to have a client who's going to request the content, and it looks like it's going to go over to the origin, but what's actually going to happen is that DNS is going to intercept it and push them to the closest edge server. That edge server, if it does not have the content, it's going to go back to the origin. The origin is going to send the content back to the edge server, and that cached copy is going to be sent back to the user. The next user that comes is going to hit the edge location, and it's just going to send the content right back. So change colors here. The next user who comes in, it's just going to get the content. They're not going to have to go through that whole process. If the content expires, then they're going to have to do the same thing all over again.
Michael, I know we touched upon this before, but does this really make sense to do with, you know, an API rather than S3 bucket? And let's say the data is dynamic, right?
Right.
From an API, data will always be different depending on what you ask. So, you know, caching in CloudFront doesn't really make sense, but still, the edge locations will help depending on where the request comes from. So is that a good use case?
Well, some API content can be cached, but even if you weren't caching it because it was 100% dynamic, because you know, let's say you weren't caching your reads because they change a lot, it's still going over Amazon's high-speed backbone. I still don't think that's as good as a use case as if it's static content, but it is faster over CloudFront's backbone. So I think the proof is in the actual application, but it is going to perform faster. Is it going to be as fast as caching content? I don't think so, but that's my perspective. Again, I think it would depend on your workload, but APIs can be a good use case. You just have to test it. Does turning on CloudFront improve performance for the cost that you're going to get, or does it really not improve performance significantly enough for anybody to care? I think it also depends on how far the user is from the source.
Well, that's the thing. Like, that's hard to test because then you have to test from different geographic locations to see whether this actually helps or not.
Yeah. Yeah, usually what we do is we start VPNing into different locations and then route our requests through those VPN servers back out to test. But you're right, that does not even come close to actually simulating user traffic if you don't know where your users are at. You know what I mean? Or even if you did, it's hard to replicate that.
You'd set your time to live then to 0, I guess, to stop it from caching.
For that content, yes, and you can do it on a per file type basis as well. So if you're like, hey, I only want to cache these file types, others don't cache, you can do that.
Okay.
Yeah, it's got a lot of granularity inside of it. CloudFront requires you to configure some kind of source, which is either a, some kind of endpoint, right? Which can be an S3 bucket, it can be an HTTP server. Basically anything that serves out web traffic can work for this, right? Then you create what's called your distribution, right? So that's just like a streaming distribution. It tells you tells CloudFront where are the source files at? Where am I going to get these from? You can also do things like force SSL, set time to lives, that kind of thing. CloudFront's going to assign a domain name to your distribution, and you're going to use the domain name in your DNS name. So if it's www.amazon.com, when you resolve that, it's actually going to go to a CloudFront name. It'll be like alphanumerics.aws.cloudfront.net or something along those lines. By default, CloudFront's not going to precede your content, but it will precede your configuration. In other words, it will send out your configuration to all the CloudFront servers, so they know where to pull things. So your origins are basically the source of your files. So you can, by the way, protect your origins by making it so that only CloudFront can get to your sources. So you can make it so that no one could get to your S3 bucket except someone using, I think they call it an OIA, an origin access identity, or using pre-signed URLs or signed cookies. Pre-signed URLs do change the URL that you use to access, for example, S3 and whatnot. If you use pre-signed cookies, or signed cookies, then obviously that's not as much of an issue. So what my point is that you can actually set up security between CloudFront and your origins, whatever your origins are. So you can also, by the way, set it up with origin failover that says, hey, if this fails over here in this region, go over here to this region, right? So you can create a primary and secondary origins in order to support failover. CloudFront has some interesting, like a couple of like design configuration choices. You can set your time to live. You can set the maximum. You can set the default. If you use an if modified since header in your GET requests, you can request and say, hey, look, I want to go, straight to origin if it hasn't been modified since this time. Yeah, there's a bunch of options here actually. SSL certificates. Path pattern matching, like you can like do regexes to match certain files as being, a CloudFront distributable versus going back to origin. There's a lot of granularity. There's a lot of features. You basically can control your request and response behavior both from CloudFront to the client and from the origin to CloudFront. So you've got 4 opportunities to modify, 2 for request and 2 for response. Here's an example, by the way, because in general, you're only going to cache static content, and even AWS will tell you that. However, dynamic content or unique content is going to affect the performance of your application. So you might still get some performance gain by caching or, networking that unique or dynamic content in, if it's like located in S3 as an example. But really good use cases for static content would be things like any static assets like videos or images or client-side JavaScript files. You want to optimize, by the way, for write once, read many times. You can also, by the way, geo-block or geo-restrict your CloudFront content as well, like prevent users from specific locations to access your account. If you use the CloudFront geo-restriction service, you can restrict it at a country level. If you want more granularity than a country level, you have to use a third-party geolocation service to restrict access to that file, right? So if you want deeper granularity, you have to use a third party. So CloudFront is your content distribution service. That's what it's really used for. Now, CloudFront is going to solve some problems for you by basically providing caching. What if we need something a little faster? Well, what you can do to optimize network performance for sensitive latency workloads is basically use Global Accelerator. Now, without Global Accelerator, if you deliver applications to your global users over the public internet, you're going to find inconsistent availability and performance because they're going to have to traverse through multiple public networks to reach your single application. These networks can be congested. You got availability and performance risks. If it's like a critical workload, you might even have higher availability requirements. This is several challenges that you can't control because you cannot control internet weather, which is what I call the random traffic capabilities of the vast public internet with its whatever 9 tier 1 providers, right? So with Global Accelerator, it's basically a networking service that improves the availability and performance of the applications that you're offering on AWS. So what happens is that AWS uses their global network to direct internet traffic from your users to applications. And what it does is, since it's routing traffic over Amazon's backbone, it makes your users' experience of your application more consistent. So it monitors, by the way, the health of your application's various endpoints, and it will route traffic to the closest healthy endpoint, which, by the way, they could be in multiple regional data centers. They could be in multiple regional availability zones. So, and it will provide a single static IP address that acts as a fixed entry point into your AWS hosted application, even though that application might be scattered in 5, 6, 20 data centers. Now here with Global Accelerator, here's an Anycast IP, let's say 54.89, et cetera, et cetera. If someone hits that, and by the way, you can bring your own IP ranges to AWS if you want to go through that challenge. It will now push to whatever data centers are closest, healthiest active endpoints for if someone hits that static IP address. So what happens here is that users are going to go to the closest available endpoint. Now, you can have multiple static IP addresses if you want, so they can actually go closest to whatever data centers are local to the entry in question. But you can associate these static endpoints like to static IP addresses to network load balancers, EC2 instances. You can associate them with IP addresses in one or more regions the world over. So it's going to route the user to whoever's closest, right? This, by the way, includes the health of the endpoint, any weighting. You can configure weighting and say, look, I want you to favor this endpoint over others. So there are some emerging policies that can use, including the health of the endpoint, the user's location, and the weights that you assign to the endpoints. Because you might say, well, look, US East 1 has far more capacity, so I would prefer that you go there, but maybe that doesn't trump the user location, which I'm in the EU, so let's go over to EU Central 1, right? Notice here that if AP Southeast were to go down and someone were to attach to that endpoint, it would automatically redirect them to EU Central 1 based on the configuration. You can also, by the way, increase or decrease the percentage of traffic that you're routing to a particular endpoint based on like 2 or 3 different regions. So you can do weighted distribution of traffic using Global Accelerator. It does support TCP and UDP. So since it is an Anycast address, by the way, just note that it will not deal with like IP fragments or reassembly. If that's something of concern to you, just be aware of it. Let's see, Direct Connect, by the way, will have some issues. It doesn't advertise prefixes for Global Accelerator over a public interface. So just know if you're having trouble resolving it through a Direct Connect connection, sometimes there's some challenges there. Now, how do these compare? So CloudFront is a layer 7 web-based proxy, basically. So it's for web-enabled applications. Global Accelerator will do any protocol. CloudFront will cache. Global Accelerator is not cache. It's only redirector. It's only load distribution. CloudFront is a DNS-based routing, whereas Global Accelerator uses Anycast. The IP addressing for CloudFront, I think CloudFront actually does have fixed IP addresses now, so that's a little weird. Global Accelerator, by the way, you can get globally static IP addresses, whereas CloudFront right now, I think has dynamic and has static IP addresses. Failover, by the way, can be origin based, right? And it's, it can based on, health checks or DNS, whereas Global Accelerator will check the endpoints, which is also a health check in 30 seconds or less. It doesn't require DNS though to function, which CloudFront does. Basically, CloudFront can hook into any service that supports web-based protocols. Global Accelerator, since it's a layer 4, is going to hit networking instances. So either elastic IPs or network interfaces, of which load balancers and EC2 instances have network interfaces. So this is why this is being emphasized. So Global Accelerator is used when you need global load balancing at layer 4. CloudFront is used when you need caching and you want it for a web-enabled application. That's really it. Oh God, I hit the wrong buttons there. Sorry. Let's go forward a little bit. Okay. Any questions about either CloudFront or Global Accelerator at this point in time? Now, if you've been in the news, you've probably seen distributed denial of service attacks happening. Like you read about people getting knocked offline, like Cloudflare got knocked offline, I think day before yesterday, or was it yesterday? I can't remember. And so what happens is that these huge bot networks are basically tying up and trying to knock a service offline or they're trying to make the service so expensive to run that people can't afford it, right? Now, distributed denial of service attacks can be isolated on whatever layer they want to. So this can be either layer 3 or 4, which is the transport and network layers, which are typically the attacks that are usually run. This is the most common type of attack, right? Has like things like SYN floods and whatnot. And then there's layer 7 of the OSI model, which these are application or web-based attacks, right? These are similar to like SYN floods, but what they're trying to do is they're just trying to overload the infrastructure, or they're trying to inject SQL and other code inside the URLs to kind of break it. Now, AWS comes free with Shield Standard, which protects all AWS accounts by default. And this is inline attack mitigation. So Amazon's always trying to protect their infrastructure, and they are really good at it, frankly. Now, the other thing, other than filtering using Shield, which by the way, there is an advanced Shield that you can pay for, and it gives you dedicated access to a dedicated team, plus some cost mitigation, right? But in addition, you can also put a web application firewall in front of your layer 7 stuff. This WAF is different than Shield. Shield operates at a network layer. WAF operates at layer 7. And what you can do is you can actually create rules that prevent malicious traffic from coming in. Now, WAF can sit in front of all kinds of things: CloudFront, application load balancer, an API gateway, AppSync, right? So just know also you can route these logs out. And the web ACL rules at the bottom are basically rules that say, hey, this type of traffic is legitimate user traffic. This other type of traffic is not legitimate user traffic. Rules, by the way, can be AWS generated, or you can generate your own custom rules. So it's up to you. And the components of these rules basically are a rule statement that says, hey, from this IP address, as part of this rule group, if you match this, then either allow it or deny it. So each rule contains an inspection criteria and an action to take. Do I allow it to go forward, or do I block it? So you can group rules into what they call rule groups if you want to. But web ACLs are pretty powerful tools for blocking malicious traffic from getting into your web application. You can do all kinds of things like attack prevention. You can do traffic filtering. You can match strings, regex, sizes. You can do conditionals such as and, ors, or not statements. Are those conditionals? That's probably not conditionals. That's probably not the right word to use for that. But basically linking and exclusion, right? Now, if you have a bunch of these rules and you want to distribute them to a bunch of web application firewalls, then you would use the AWS Firewall Manager. So this basically allows you to distribute your standard rules across an entire set of WAFs across a bunch of applications. This is typically used when security needs to enforce standards across an entire enterprise. And so teams can have some local rules that they control, but the Firewall Manager pushes consistently the same set of rules for the entire enterprise. So obviously that can become problematic, but just know you can en masse manage your WAFs. So this is if you have a large number of accounts and resources, you have new applications being created all the time, and you want to automatically throw a WAF in front of them. This allows you to centrally see all of your enterprise-wide threats. This combines well with, by the way, the organizations thing that allows you to manage multiple accounts at the same time. This works really well with that. Okay. Here, by the way, is a distributed denial of service resilient reference architecture. Notice they didn't say like resistant or impenetrable infrastructure, because really nothing is. Here's an attack coming in and it's trying to get to layer 4, which is blocked by Shield. If it's going to layer 7, it could be blocked by WAF, right? And the Firewall Manager is distributing rules to all the various WAF devices. This kind of combination with Shield and WAF in front of some kind of object is pretty standard, actually, if someone needs it. I've only worked for 2 companies where if you literally stuck SQL, like drop table. I don't know if anybody remembers XKCD, little Bobby drop tables. But if you stuck SQL in the end of the URL, it would literally execute against the production database. I remember having a long discussion, like, we need to parameterize this. And they're like, why? We want to accept all inputs. Do we? I don't think we do. Yeah. Can you imagine some user coming in and just randomly dropping your production database tables? Now, they do have to know the name, but you could probably do a select star and get some kind of response. Anyway, that's a whole different discussion. Yeah, there was a cartoon called XKCD that had a thing called, and it was like, hey, your son hacked the school. And it's like, yeah, he used to drop tables or something. It's like, yeah, we call them little Bobby drop tables. So it's like a joke for that. XKCD was ahead of its time. All right, so let's talk last about Outpost, and then we're going to squeeze in this lab. Maybe, maybe not. You know, we might take lunch early. That might be another option, is that we might take lunch early instead, because we really need about 45 minutes to really pull this lab off. So yeah, maybe we'll take lunch early. Okay. So our customers require that their servers be on site with high availability. Okay, cool. So Outpost Solutions basically says, well, how do we deal with an application that needs to stay local for security reasons, but we want Amazon's benefit and infrastructure? Fair enough. So what can happen is that you can request from one of Amazon's partners, you can request that you want an Outpost rack or stack delivered to you. You do have to have an enterprise support plan. So just so you know, this is only for enterprise companies, right? So basically, they assess the site, Amazon works with you, it's a physical location, and they're going to verify your site meets requirements, and then they're going to schedule a date and time for you, including a checklist, and they're going to roll the rack to the identified site and allow the electrician or whoever to hook up the rack in question. So once the installation is complete, you got access basically locally inside your data center. Once that's verified that you can actually see Outposts inside your AWS account, the team leaves, but you have EC2, EBS. I want to say that ECS is in there, not ECS anywhere, but ECS. RDS will run inside of Outposts. There's a bunch of things actually that will run Outposts, even more than probably I even remember. And so here you've got EC2, EBS. Oh, okay, RDS is there. ECS and EKS, EMR will work. Basically anything that uses EC2 as an underlying service will most likely work. Obviously your managed services aren't going to function. You're not going to get DynamoDB out here, right? But RDS uses EC2 t-shirt sizes, ECS and EKS and EMR all use EC2 as a t-shirt size. I don't know what S3 uses, but I don't think it uses actually EC2 instances. So these are local services that you can run inside your data center. Okay. Knowledge check before we come back into labs. What are the potential benefits of implementing a CloudFront distribution? Increase application security and reduce latency. Yeah, that actually sounds good. Increase application security and reduce latency for access to application content. That's true. By the way, which service gives you 2 global static IP addresses? Which service does that? Yeah, that would be B over here, Global Accelerator. So yeah, that's good. Automatic redundancy for all application content. Man, if there was a service that just did like automatic redundancy for all application content, that'd be a great service. They're probably talking about some variation of CloudFront there, but still, it's interesting. Okay, which of the following services offer distributed denial of service protection, either at layer 4 or layer 7? Yeah, Shield and WAF. Ed for short. Good. Okay, so let me put this out because one no vote could shift this whole thing. We can start the lab, but we probably won't finish until 12:15. Or we can take lunch now and we'll come back, at 12:35, 12:38 or whatever. And we can do the lab, but lunch won't run until 1. It'll go earlier. It'll start right now. So I'm gonna do the lab first. Does anyone absolutely like, no, I cannot stay past 12 or, right? No. Okay. Let's do the lab then. All right. First thing, do me a favor while I'm talking about it, please roll over to your Quick Labs account and please go ahead and hit Start Lab because we pre-warmed these labs a little while ago and sometimes they will stop being pre-warmed, which kind of stinks, honestly. So go ahead and hit Start Lab for me if you haven't already done this, and I'm going to talk about the lab. So what we're doing is we're setting up a CloudFront distribution, which is actually fun to do, actually. So we're going to look at an existing CloudFront distribution. We're going to create an S3 bucket. That's going to be our origin. We're going to configure the bucket for public access. So we kind of like get to see how that's done. Then we're going to upload an object to the bucket and test the public access. And then we're going to create our CloudFront distribution. So we're going to add it as an additional origin to the existing CloudFront, secure it with what's called an OAI, an origin access identity. And they're going to test access. It's really that simple. So by the time you're done, you'll just have this set up. But just so you know, your distribution is actually set up for you automatically, but you're going to add in another origin to it so you can actually see all the configuration. Now, in this lab itself, oh, sorry. Oh, man. Did I do the wrong one? Oh, I did do the wrong one. Hold on. Huh. Did I mess that up? Did I do that out of order? That's weird. Hold on one second. I'm pretty sure I didn't do that out of order because I'm really good at that. Oh, that's weird.
Order.
Oh, that's weird. They got the labs crossed. Oh, that's so interesting. They got the labs crossed. They're in the wrong order in the system. That's why I pre-warmed the wrong thing. So anyway, did anybody already hit like, all right, so let's switch over to lab 6. So I'm going to pre-warm the labs, but quite frankly, they're not going to warm up quick enough for you not to run into a provisioning challenge. So, oh man, that's an interesting bug inside the structure. Does anyone see what I'm talking about, by the way?
Lab
So
5 instead of lab 6. Sorry.
Yes. So what happens is that we actually just finished the Edge module, but it looks like they mixed up the ordering of the labs because we haven't covered serverless yet, which is what lab 5 is going to cover. So
I have the opposite order in my copy of the book.
Really interesting.
Yeah, like our copy has module 11 as a serverless, and then module 12 as module 12 is this one.
Really?
I don't have that. I have it in
You-
the same order I'm seeing right here.
Yeah. So it seems like there's some confusion about some mistake inside the lab guides. All right. So since we just finished Edge, my recommendation is let's switch over to lab 6, right? And let's do this lab because this is the one that's relevant for the topic that we just covered. The other one, lab 5, is actually for serverless, which is the module we're supposed to cover next. And I'll get to the bottom as to why this is set up incorrectly. Bottom.
Should we just end lab 5 because I already started that?
Yeah, go ahead and end it actually.
And is lab 6 available? Because for me, it just looks like a warning sign with exclamation sign. Can't click on it.
Let's try it. Try it now because it wasn't activated.
Yeah, now it's better.
Yeah, there you go. Technical trouble. All right, so this one, and again, if you hit start lab, it might take a second to start, but while we're going through it, hopefully it'll in queue, is that we're going to explore an existing CloudFront distribution. And then what's going to happen is that the CloudFront distribution already has an existing origin. We're going to create a new origin to add to the existing one. And then we're going to configure the S3 lab bucket for public access. So the one that we just set up, we're going to make it public, which is going to be fun because you're going to remove the block public access, right? And then you're going to create a public read policy for this S3 bucket. Then you're going to upload an object into the bucket. You're going to test it. And then you're going to add the bucket as an origin into your CloudFront distribution. And then you're going to actually turn on security by enabling OAI, the origin access identity, which only prevents CloudFront is the only one that can then talk to S3. And then afterwards, you're going to direct test access file in the bucket using the S3 URL, which should come back rejected, right? You should see an access denied. And then you're going to test the object access through CloudFront. So, and then task 9, which is an optional task, is what if you wanted to replicate a bucket across regions? So you're going to actually do cross-region replication, which that's fun too, actually. That's it. Now, a point of curiosity, how many of you are seeing right now where it says provisioning resources?
I have 5 minutes left.
Okay, 5
Yeah.
minutes. 5 minutes is acceptable. If it was 10
I
or
have 3
15,
minutes left.
that would be painful. Good. Erica, so in case you missed the little bit of drama that we had earlier on me, not you, is that it looks like, at least in my setup, both in my slides and in my guide, and in some of the student guides, but not all of them, lab 5 and 6 have been reversed.
Yeah,
So-
sorry, I typed that before we figured it out.
Oh, yeah. Oh, okay. Sorry. Was that a few minutes ago? Am I just seeing that?
Yeah.
Okay. Yeah. So we're on lab 6.
Yep, I got it.
Sorry, I'm behind. Huh. Now I am so interested in how you ended up with 2 different student guides and how come my guide wasn't updated. Anyway, I'll stop sharing so you don't have to look at all my instructor guides.
Mike, I'm not able to start the lab 6. I'm getting an error.
Okay, Arpan, what's the error say?
Says lab failed on Wednesday, 17 November 2021. Cloud formation stack returned nil.
Okay, just end it and restart it.
It's not even allowing, it's a start lab. When I click on it, I just get the error. It doesn't really let me do anything.
Can you share your screen?
Yes, I can. This is weird. I can't even share.
So how do we go from here to an executable series of Lambda functions? So obviously with Lambda, you just give it your code. There's no servers to set up. You just define the size of, the memory space and processor that you want for your application, what the trigger is, what its permissions are, and you just let it go to town. So you're literally just paying for execution, right? And it does it by the millisecond. Used to do it by 100 milliseconds. And no servers to manage. You just set up your runtime execution, give it your code, answer a few questions, and you're done. Now, the serverless portfolio, by the way, includes a bunch of other products that are also considered either on-demand and or serverless, meaning you don't manage the servers. But when we talk about like functions or code as a service, we really are just talking about Lambda on the upper left-hand side. Associated with that is usually other things like API gateway and whatnot, but and step functions. But Lambda is really the heart of this. Here, someone uploads an inventory file into an S3 bucket. That generates an event notification that triggers Lambda to insert some results into a DynamoDB table, which then is consumed by a dashboard app. The DynamoDB table in turn triggers some updates because Lambda is polling the table, and it sends a notification to somebody and says, hey, got an uploaded set of inventory, right? So this is a loosely coupled, highly scalable workload. Notice there are no servers involved in this. Total cost of ownership is basically when it runs is what you're going to pay for. Otherwise, you're not paying for anything. So these are the solutions that can support this kind of infrastructure. So in addition to Lambda itself, which we talked about before, just allows you to run code, there's other ancillary kind of buses and notification services and real-time streaming services and orchestrators that are appropriate here, right? So API gateway is how do we set API versioning? How do we do caching? How do we do rate limiting for our APIs? API gateway is interesting because kind of like how an ALB, an application load balancer, can have Lambda as a target, the API gateway is almost like, in a sense, a slightly different kind of type of load balancer for an API, but it's a little different that it's actually not there to balance load. It just adds a bunch of features in front of an API. API gateways, by the way, are an industry standard. There's several kind of companies who run them. Amazon's does the things that you would expect, like it does authentication, it can do caching, it can do metering and rate limiting, it can do versioning, it can do all this crazy stuff. So when you connect to an AWS service, you have three ways to do it. You can either go through the management console, through the CLI, or through the CDKs, and you connect through an API to manage the resources that you create on the back end. Well, when you use an API gateway, that's all you're doing is you're surfacing an API, because you can use API gateway to create, publish, monitor, maintain, secure APIs. And you can connect it to not only APIs on AWS's website, you can connect it to your own APIs, and you can also connect it to APIs that are on premise. So it can handle hundreds of thousands of concurrent API calls. This includes authorization and access control, traffic management, API versioning, all of that. So this is a unified front end with multiple defined endpoints or methods on the back end that you can use to host multiple versions and stages. So you can have like version 1, 2, 3. You can have them in, development, production, staging, production, and you can actually distribute API keys to developers who request them if they meet the right authorization You can either use RESTful or you can use WebSocket APIs. Either one's fine. This also provides distributed denial of service. You can also meter it. So you can say, look, you only get 50,000 calls a day or some variation thereof. It basically allows you to monetize APIs, which, you know, it's been a pretty common concept for the last 3 or 4 years. Here's a sample gateway architecture. We got clients who are connecting to the internet and they're hitting CloudFront. CloudFront is sitting in front of and surfacing the API, which is actually sitting on the API gateway. So API gateway integrates in with CloudWatch because it'll send log messages and detailed metrics to it, right? And you can activate logging for all the detailed stages of your API. You can see full verbosity of logging, right? So the metrics, by the way, the API can send to CloudWatch are API calls, latency, integration latency, right? You can also activate access logging to see who's accessing your API as well. So CloudFront and API Gateway work together to secure and log at a little more deeper level. Obviously, CloudFront will do caching of APIs if you wanted to. So just remember, API Gateway is an industry, API gateways are an industry standard, right? I'm trying to think of all the companies. Oh man, that I know. MuleSoft was one of them. Apogee was another one. They got bought by Google. There was another one out there. I can't remember all the different names, but this one functions a very similar way. It basically acts as a proxy, adds a bunch of features in front of an API. Okay. All right, so that's an API
Hey, Michael?
gateway. Yes, Raj.
Hey, so on my project, we are trying to use MuleSoft proxy
Mhm.
and then use this API virtual private VPC and subnets. So how the MuleSoft and this API, in that case, we don't need API gateway, right?
Not really. I mean, depending on what you're paying for MuleSoft. MuleSoft has a bunch of products though, so I'm not familiar with their entire product suite. But I'm pretty sure that proxy, if it's caching APIs, will act very similarly to API Gateway. Is there a need for double proxying for some form or fashion?
No, I don't think so. Yeah,
Rajesh,
I
that
was
might
thinking-
be enterprise standard. I think for some coming in from the internet, I think they're saying we have to go through a MuleSoft API. Like that's just kind of our front door.
Ah, I gotcha. In other words, you might be doing what I saw at Honeywell, where they had a meta front end that centralized all the APIs for the enterprise, but individual people who were hosting those APIs also had caching and rate limiting, so they could control that because they couldn't control the centralized, right? So that might also be in play as well.
It could be. It could be.
Yeah, I don't know, Raj. I'd have to see what the use case was for why they want to do that. But that is actually something I've seen before at Honeywell for larger enterprises, is they have a kind of master like proxy that surfaces all the APIs for the internal company and everything centralizes there. And all the different like groups have their own APIs, sometimes with proxies themselves, so they can surface them back up. And you just end up with a double proxy situation.
Okay, yeah.
So they should be able to tell you why that is though. But if Alex is saying that that's a standard, and maybe, for example, there's a feature inside of MuleSoft that isn't available inside of API Gateway. Amazon tends to make services that satisfy 80% of customer needs, right? But they're definitely not as advanced on any of this as the kind of native tools, if you will.
Well, I mean, we have a mishmash of APIs that are both, you know, AWS native and, you know, on our on-prem site, right? So I don't know if you can, if they would ever want to use the API gateway specifically from AWS to be the front door for everything.
Yeah.
I have a feeling that you kind of need the MuleSoft, and then if you're routing to an AWS API, you would actually use the AWS API gateway as well. But anyway, there's all kinds of diagrams and standards that they have on the enterprise site that shows the patterns. But I have seen what you're talking about. I just don't know 100% why they did that, right? So what I remember seeing is all incoming traffic from the internet has to go through a MuleSoft proxy.
Been there.
Yeah.
Yeah. Been there. Okay. So it's going to be a little bit of a mystery. Oh, by the way, I did look for the Fargate limitations, just to mention this as a little sidebar while you were all working the lab. I literally looked for 20 minutes and I could not find the limit, like an up-to-date document that showed me all the limitations for Fargate, which really threw me off, honestly. So I actually sent an email over to AWS and asked them to send me the limitations, but it's not in the documentation anymore like it was. I'm going to figure it out though. Okay, so API gateway, proxy with some features added for APIs. Can integrate great with CloudFront, right? So SQS though is a different beast. Now SQS, oddly enough, was the first service launched by AWS right before S3. S3 was next, and then there was a bunch of others after that. So what if you just need a messaging queue, right? Well, remember, this is the simple queuing service. So this is not a fully managed queue. So you never see the servers involved in this. But it basically stores messages until you either hit the deletion timer, like they expire, or until they're deleted, right? So this is actually has a buffer when you need to transfer a bunch of messages to somebody and have them picked up by people, or, entities that are going to process them. So this is great for like order management. If someone dumps a bunch of orders and they're coming from your web servers, and you don't want to overload your application servers that are processing these orders, you can just dump them into this queue. And what happens is your app servers will just come and pick them up as they see fit, like as they can, right? So SQS, by the way, can be shared. It can be restricted by IP address and time of day. You can encrypt everything. It works on a massive scale. It can host billions of messages easily. So without SQS, what ends up happening is that you have direct producers basically pushing to like order consumers, right? Think people are going to process, entities are going to process the order and then do something with it, right? Submit the order, execute the order, right? So if there's a sudden stress against the producer end, it can easily stress the back end, which has maybe in a sense fewer consumers on it. If you throw a queue in there, what happens is that you can't really overwhelm the back end, but obviously order processing can get slow. And what will happen is it will go and read all the messages, process them, and then when it's done, there's nothing left to process. But that queue basically acts as has a placeholder to handle all of the messages that are being sent from the front end to the back end, which is a great use case for SQS. By the way, if an order can't be processed for some reason, it can be sent to a dead letter queue, which is actually sent up top. And you can randomly have either another processor or one of the processors check the dead letter queue and say, hey, it's been an hour. Is anything in the dead letter queue? Let's see if there's something there, right? For reprocessing. Now, in this kind of setup, I'm trying to figure out, oh, they just added the thing on the side. This makes things very loosely coupled because you don't care how many web servers are on the front end. You may not really care how many servers are on the back end. But just to say this, one cool thing about SQS queues is that they can be set to talk to an auto scaling group. So if you have servers on the back end and you don't have enough of them to process these orders in time, SQS can tell the auto scaling group to expand based on the number of messages in the queue. It's actually a really good setup. So if all of a sudden you're like, wait, we've got 5,000 messages in the queue, which means it's going to take us 5 days to process. We need to get that down. So I want you to expand the number of servers that are doing processing. SQS can trigger expansion of an auto scaling group. So kind of nice. SQS's basic use case is it's just offloading. That's all it is. It is asynchronous offloading. You're just dumping it into a queue. So whether that's a work queue, if you need it standard, or if you need it ordered, like first in, first out, if you need buffering and batch operations, that's what it is. It's just an abstraction layer where you can dump tickets and messages into this queue and have them processed. That's it. Notice it mentions auto scaling on the lower right-hand side. Now there are two queue types, which is standard and first in, first out. Standard, by the way, means that message ordering is not guaranteed. Doesn't mean necessarily the message ordering is going to be horrible. Like message 100 is going to be message number 2, right? To get processed. But it will be unordered. It's not going to guarantee order. And compare that with a FIFO queue, which is first in, first out. It basically means it's going to make sure that everything's only processed once and it's highly structured. A standard queue is going to guarantee that something's going to get processed at least once, but you might need a little bit of logic to avoid duplication of efforts, especially if you don't have your timers set up correctly. There are visibility timers that are used to prevent people from double processing. If you don't have those set up correctly, or that concept seems to be difficult, then you might want to switch to FIFO. But standard queues have been around for 15 years now. FIFO for Amazon just came out within, I want to say, the last 5 or 6 years. So you have a life cycle and a visibility timeout, which basically says how long will this message stay invisible once it's been picked up for processing? Because the way this works, just so we're clear, is that when a producer sends a message and it goes on the queue, a consumer reads the message, processes it, and then once they're done processing, the consumer has to come back and delete it. Now, how a consumer talks to the queue, whether it's a long ask or a short ask, which is what long and short polling is also another consideration. And then dead letter queues are used for things that for some reason we're about to be deleted off the main queue. So we're going to send it to the dead letter queue because it's like, wait, you've been here for 14 days. How come you haven't been processed, right? That kind of thing. So in this diagram here, what happens is that a producer, let's say it's a web server that just received an order, produces a message, like a ticket, if you will, and it goes on the queue. First of all, it's automatically replicated a couple times. And what will happen is that this queue, which is a temporary repository for messages, will stay there anywhere from 1 to 14 days. I'm sorry, let me rephrase that. It might stay up there for 1 minute. It might stay up there for 14 days. The default, by the way, is 4 days. 14 days is the max that a queue can hold messages. So what will happen is that this message, which by the way, cannot be bigger than 256 kilobytes in size. So this isn't a database, right? This is literally a message, 256K. What will happen is that the message is distributed redundantly. And then what will happen is that the consumer comes and reads the message, and that triggers what's known as a visibility timeout. So the default is 30 seconds, but in this particular case, they have it set up for 45 seconds. The maximum you can set your visibility timeout is 12 hours. So this is significant because if your visibility timer expires before the first consumer finishes processing the message will become available again on the queue, and another consumer can come and read that message and will start processing it because the first consumer didn't tell SQS to delete the message. This guarantees, by the way, that the message is processed at least once, but it might be processed duplicate times if you don't have a mechanism to check and see if that message has been looked at before. So
Mike, when you pop the message, doesn't it not delete it automatically, or do you have to specifically go back and say that deleted has successfully been processed or unsuccessfully been processed?
it's a two-stage process. The consumer has to go back and read the message and then process it. And once they're done processing it, when they read the message, they got a read receipt. They have to go back and take that read receipt and delete the message. But you can only delete the message if you've read the message. So it's a two-step process. So if that second step doesn't happen, where the consumer has read the message, but they finished processing, but for some reason they failed and they didn't actually go back and delete the message, what will happen is the visibility time will expire. The message will become visible again inside the queue and someone else will pick it up. Okay. So this way they guarantee it's processed at least once. So the way I usually solve this, by the way, is that when I'm writing code for the consumer, I'll have the consumer check against the database and I'll put a unique ID into the order, right, into the message. And so I'll have him check and see if the unique ID has already been processed up at the database, so that if a system finishes processing, they write to the database, and let's say they crash right before they finish deletion and someone else picks it up, the first thing that the new consumer is going to do is it's going to go check the database and see if this message has been touched. If it sees that that order ID is there already, it'll say, hey, this message has already been touched, and it'll go delete it off the queue. So I usually put application logic in there to deal with issues around duplication. General rule of thumb, set the visibility timeout to the maximum time that it takes for your application to process and delete a message from the queue. In other words, if you know that at most, worst case scenario, it's going to take 30 minutes for you to process a message, worst case scenario, right? Then that's what you set your visibility timer to. If average is 5 minutes, but worst case scenario is 30, you set the timer to 30. That way, if you pull a message and it takes you 5 minutes, great. If it takes you 10 minutes, you don't panic. If it takes you 15 minutes, you don't panic. But when you get to 29 minutes, hopefully something has failed and you want somebody else to pick it up at that point in time. So customer picks up the message, the visibility timeout starts. The consumer must delete the message after it's been processed. Again, before the timer expires. If the timer expires before the message has been processed and then deleted, again, it gets submitted again for, hey, someone pick me up, someone process me, right? Now, the other thing to know is, how do the consumers go to the queue? So I always like to joke about this. When you use short polling, which is unfortunately the default, what happens is that you will come to the queue, the consumer who processes the orders will come to the queue and say, hey, do you have any messages? When you use short polling, the system only checks like a couple of the backend servers that make up that queue that you can't see. And if those servers don't have any messages, short polling is like, nah, we don't have any messages, go away, right? And you know, the problem with that is that there could be 50 servers in that are actually part of that SQS queue at any given time. And you might actually want to know if there's any messages anywhere on the queue at all, right? And so in order to do that, you have to use long polling. Now, long polling is different, because what happens here is instead of you like knocking at the queue door going, hey, do you have anything? And the guy's like, hey, Johnny, Mark, do you have anything? No. And it didn't talk to the 20 other people who were in the room. Instead, with long polling, you know, you knock on the door and you're like, hey, do you have any messages for me? And what happens is with long polling, it asks every single backend server that's on the back end. Mark, do you have anything? Johnny, do you have anything? Do you have anything? It asks everybody. Do you have a message? No? Okay. That can take longer, but since it's a single API call, it ends up being cheaper for you, because instead of like, do you have something? No. Do you have something? No. Do you have something? No. It's, hey, do you have something? And the queue goes, wait, up to 20 seconds. It'll let you hold that connection open. At second 19, it might come back and say, hey, I just, talked to this server. It's got a message here, take it, right? Now, obviously I humanize that whole thing, but you get the general idea, right? Is that long polling allows you to talk to all of the servers that make up the queue, whereas short polling is like just a few servers. All right, the dead letter queue, outside of how messages work and how polling works, is really just used once you've hit like a max number of retries. So for example, this is an SQS queue that receives messages from other SQS queues, referred to as source queues. And so let's say that someone tries to process a message and they're just unable to process it. It's been read like 5 times. At that point, the dead letter kind of rule triggers in depending on what you configure, and it basically moves it over to a dead letter queue and says, look, man, there's something wrong with this message. It's not processing. So what you can do is then have the Lambda function go in and maybe it retries with different parameters, like maybe it takes longer or whatnot. And then what happens is then it can go to a different dead letter queue, which then says, hey, I need human intervention. I don't know why this is failing, right? Caveat about dead letter queues is that they have to exist in the same account in the same region as the other queues, the source queues that are going to use them. So keep that in mind. So messaging use cases. Service to service communication, asynchronous work items, buffering, queuing, batching, state change notifications. These are great use cases. Again, just to ask this question, did anybody hear me earlier? What's the largest size that you can stick on an SQS queue? What's the size of those messages? What's the largest amount of data you can put on there?
256.
Yeah, 256K. You can use like for example, the Java SDK has a special development kit feature just for Java that will allow you to like somehow do some kind of meta batching and process a gig of information. No, don't do that. If you need to process a larger set of information, put a URL to like an S3 bucket or something inside your message. Don't try to meta batch your stuff. But 256K is the max. Remember that number, 256 kilobytes, because the next service we're going to talk about also has a messaging limit of 256 kilobytes because they were developed right around the same time. Okay, so this is the sister service to SQS, because while SQS is a pull model, you pull it and you pull messages, SNS is a push model, meaning you subscribe to topics and it pushes messages to you once you give consent, right? So SNS is the simple notification service. This one's actually fairly old. And when I say old, by the way, don't assume that these services are not abandoned. They are highly iterated upon and constantly evolving, but it just means that they've been around for a while, so they're a little bit more mature. So SNS also has publishers, but the difference is it doesn't have consumers. It has subscribers, and you subscribe to a topic. Now, we all know this because this is just like our email list, which, you know, most of us are still horribly spammed with email, right? You basically create a topic. Let's say it's, operational events in Virginia. That's the name of the topic. And you can push a message to it, and anybody who subscribed to that topic will receive the message. Now, a subscriber can be an email address, an SMS text. It can be a web post. It can be an SQS queue. It could be a Lambda function. So just know that SNS is a one-to-many kind of pub sub model that allows you to push multiple messages to multiple sources. So one message can go out to multiple sources. So it makes multiple copies. So here messages go into the topic and then they end up on the subscriber in whatever method the subscriber agrees to. General use cases for SNS is any kind of notification, any notification. Mobile push, by the way, is one of the options. I forgot to mention that earlier. But it's also if you want to duplicate a message programmatically and kick it out to a bunch of other programs like Lambda or SQS, right? So it publishes a single message. There is no recall option. It does not guarantee order normally, right? But if you use a FIFO queue, it will guarantee the messages go out in the order that they were sent. It will not guarantee delivery, by the way. And the reason I say that is that it doesn't have control over the SMS services and it doesn't have control over email. So while it will guarantee that it delivered it to the provider, it's not going to guarantee that the message gets to the client, right? So let's see, other things, HTTP, HTTPS retry, that's for web posting. God, there was something else here that was really wanted to make. Oh, you can filter messages. So by the way, you can set conditionals on messages that say if a message contains this tag, I want you to go over to this subscriber. And if it goes this tag, I want you to go over to this subscriber. That filtering, by the way, is set up by the subscriber, not by the poster, right? So not by the producer. So here we've got a publisher on the left-hand side, which is actually pushing through SNS, and it is doing a fan out model where it is duplicating that message to multiple SQS queues. This could be useful, for example, if you're like doing a video company, which I was talking about doing that a while ago, and you need to create like 3 desktop versions, 2 mobile versions, and a tablet version of a video, but you get 1 message for the source file. SNS can just fan out and duplicate that message to 3 or 4, 7, 9, 10, 20 queues. And those queues will all get the message, but maybe each queue has a different video resolution that it's processing for. So that fan out scenario is a common design pattern when trying to go from a 1 message to a many message kind of setup. This allows, by the way, if you publish it to multiple queues like that, parallel processing. So all that can get processed with separate Lambda functions all at the same time. So we love that. Now, just a quick contrast here. So SNS is not going to hold on to messages. It's going to push them and dump them. SQS will hold on to messages until you delete them. SNS is passive because you subscribe and then it pushes messages to you. But SQS is a pull or poll model, which means you have to go to the messages and pull them down. Definitely SNS is pub sub, and SNS is definitely a one-to-many model, whereas SQS is meant to provide 1 message for 1 consumer, 1 message for 1 consumer, whereas SNS is a many-to-one relationship. So that's SNS and SQS. Any questions?
So I'm still a bit confused when you said that it does not guarantee delivery, because I mean, that's the whole purpose of this service, right? That you,
Yep. I mean, yes, to notify, but
Yeah.
once it leaves the system, it can't guarantee the delivery to the end client.
No, I
Because
understand that. So I mean, your question of a video processing, right? So if I have a video that I just shoot, and then I drop it to SNS, and then if I want to create a file that's compatible to say MP, whatever, iPad or iPhone and things like that. So there's a different, I have to make sure that it gets delivered to those queues so that those processes can pick it up and format that. So that is a responsibility on the SNS to make sure that it gets there. The delivery happens, right? I think you're on mute.
Sorry, if it's an AWS, here's a better qualifier. If it's an AWS service, it's guaranteed to make it. But if it's not an AWS service, it does not offer guarantees. Right, because it has no control over that service.
Okay.
Right, because it'll make the post, but what if it makes a post and the other side doesn't respond? But with a service that it controls like SQS, it can guarantee that SQS is up because AWS controls those services. So it'll guarantee delivery from a service perspective. It won't guarantee delivery to the end client because there's other transport mechanisms involved that it doesn't control. Like email is just fraught with peril, right? Because email servers are cantankerous and, up and down for the most part. Now we've gotten that pretty stable over the last like 5 to 8 years or so, where that's less of an issue. But SNS isn't going to offer any kind of SLAs or guarantee other than the fact that it's going to get it to the email server. It won't guarantee delivery to the client because it can't control that system.
No, that's what I mean. Like, so as long as it gets it to the email server, that's it. Its job is done.
Its
right?
job is done, and that it
Yeah.
will guarantee.
Okay,
But it
so
won't
that's
guarantee delivery to the client.
So it does guarantee that it will send it to all the subscribers successfully.
Indeed. Yes.
Okay. Yeah.
Sorry, let's see. I was looking at this, working on trend analysis. My team is thinking the way we process streaming data. By the way, when we process streaming data today, there's like a buzzword that's been around for a couple of years that was the software developed by LinkedIn. I think it was LinkedIn. I think it was LinkedIn that everyone's pretty much using for processing streaming data. Does anybody know what that is? Starts with a K, just like this one does.
Is it Kafka?
Yeah, it's Kafka, right? Just so you know, Kinesis has been around for a long time before Kafka got popular. I'm surprised Amazon hasn't stuck it in here, but for, I want to say like 2 years now, they have a managed Kafka service. Most people don't know about it, but it's MSK. It's been out for a while. It's rock solid and stable. Most of my DevOps friends do not want to run their own Kafka service because they've lost weeks of their lives keeping those things up. And so they are moving over to a managed Kafka service. It's called MSK. So just know that we're not going to talk about it, I don't think. But Kinesis has a competitor called MSK, published by Amazon, that is a managed Kafka service. This is like the comparison between ECS and EKS. Kinesis is really easy to use, operates through the same kind of general concepts as Kafka does, kind of. But Kafka is an industry standard and it's really easy to replicate, and all your tooling for Kafka works for the managed service. So I just had to throw that buzz in there because I like Kinesis, but just like the way I like ECS, it's great to get started, but if you want advanced features, you're going to end up using the managed Kafka service. It's like I was joking the other day. If you know Kafka, Kubernetes, or cloud all starts with K, then you know you're guaranteed from an infrastructure perspective a job, right? So, I think my son was like, I don't think cloud starts with a K. I'm glad you're paying attention. Okay, so let's talk about Kinesis just for a little bit. Kinesis, by the way, started out with just analytics and data streams, and then it went to Firehose and it went to video streams. So just know the job, that like goal here is how do we collect, process, and analyze data in real time. Now, I just want to say this. The term real time is fraught with peril. You've heard me use that phrase before. What do I mean by that? You really have to ask what someone means by real time. Is it 5 milliseconds? Or is it 5 seconds? Or is it 30 seconds? Delay before the data gets streamed in and then processed and then presented, right? Like when you talk to most people and I'm like, they're like, I want the data in real time. So what you're saying to me is that you want it the minute the user clicks on your website, you want it to show up in less than like a second, 2 seconds, 3 seconds. They're like, yeah. So then what happens is then when I present them and say, look, if you do 30 seconds, it's going to cost you $200,000 to run this infrastructure for a year based on your current data volume. And then like, if we cut it down to 10 seconds, it's going to cost you $400,000. If you cut it down to 5, we just went to $750,000. And then if you want it to be real time, it's going to cost you $1 million a year to run this infrastructure. All of a sudden people are like, you know what? Let's amend the definition of real time. I'd like to keep it to 30 seconds or a minute or 2 minutes, because that's usually the next discussion. There's like, what can I get for, how much will a minute cost me, or 5 minutes, right? So when someone says, by the way, they want to process data in real time, make sure you peel that back and figure out what they actually mean, because we throw these words around and we kind of mean different things, right? Kind of like the discussion our opponent and I just had. He was just clarifying actually what I actually intended to say, which I could have said better, right? Which was, hey, it does guarantee delivery to the subscribers, but not really to the end clients, which he was like, yeah, that makes total sense, right? Same thing. If someone says real time, find out what they mean, right? What do they mean when they say real time? That being said, streams, Firehose, analytics, and video streams, right, are all serving the same purpose. How can I basically collect these different data streams and do analytics on them? That's really what we want this data for. So data streams basically puts data records into what they call shards, right, into like a stream, and it goes in and then the data gets sharded out, which means the data gets segmented out based on some hashtags, like based on how the data is structured. There's a longer conversation there. I'm not going to get into that. But basically it shards the data. So it basically routes it to different kind of like shards or processors inside the Kinesis data stream. Each of those shards, by the way, can handle a certain amount of bandwidth. What does that mean? Each shard, for example, can ingest about 1 megabyte of data per second, and it can write it out at 2 megabytes per second. If you want this data stream to go faster, you have to add more shards. Just remember though, as you add more shards, if your first shard is handling A through L and your second shard is handling M through Z, and you shard the second shard because you add 2 shards to it, it's going to split M to like R and then S to Z. So just know that there's some considerations as you expand capacity inside these data streams that operates very differently than anything else you've probably used. So make sure you read the documentation on this before you start condensing and expanding capacity. Now the data stream, by the way, is going to write out, and real-time data is going to be processed by consumers who are basically just going to go and they're going to read it off the shard, right? They're going to read off the section. And so consumers are going to receive the streaming data, and it could be an application, it could be Lambda, right? And just so you know, it's going to need to scale as the data scales. So if it's an EC2 application, make sure it's in an auto-scaling group. Each consumer, by the way, is going to process a particular shard. So if you've got 4 shards, you probably want 4 consumers. If you add 2 more shards and you make it 6, you're going to want 6 consumers. Just, you can get a consumer to read off of more than 1 shard, but that's not typically how it's done, right? Is there something else to say there? By the way, once the consumer gets the data, they usually write it off to a backend data store. Redshift is usually S3, right? Usually things end up on S3 and then they end up on something else, but you know, it just depends on what your process is for data transformation. Now, Firehose is interesting because Firehose will start to process data in real time. It can also send data if you want to like third-party providers, right? So what's interesting is that Firehose will receive data producer and it will buffer and concatenate it, then push that data out and then push it to whatever, like directly to whatever data store you need. Notice that there is no like consumer here. This data is going directly into a data store or to an HTTP endpoint or directly to a third-party service provider, which could be, you know, Splunk, Loggly, New Relic, Datadog, AppDynamics, pick your poison, pick your service provider. Doesn't really matter. God, I don't know why did they do this. Amazon ES, by the way, is Elasticsearch. I don't know why they shortened that. Most people wouldn't know what that is. Elasticsearch, by the way, is a search, is a NoSQL database that focuses on search. So yeah, so Firehose is a little different in that there's no consumers in line. This one literally consumes data and writes it right out to data stores. So if you need transformation or some other kind of piece, Firehose can do some of that. But for the most part, the format's going to stay intact. It's not really for ETL. Now, I'm going to just say this, is that we're not really going to talk about the data analytics or video streaming pieces because those are a little bit more advanced topics. It basically, data analytics basically leverages either the SQL server, oh God, what's it called? Not the reporting engine. Oh, I can't remember, something with analytics, or Apache Flink. And what it will do is actually do data processing and aggregation right as the data comes in. Video streams will actually just analyze video streams for either recognition, analysis, pattern analysis, transcribing. So it's really used for when you need to analyze a stream, a video stream as it's running. But we don't cover those here. We just cover Firehose and the data stream product itself. Okay, so that was a little sample of Kinesis. I wish that was a little bigger. If you take a big data class or the analytics class, they definitely dive into Kinesis in a lot deeper way. Okay, last one. So SQS, we talked about a queue system, right, that allows you to put messages on there. With SNS, we talked about a notification system that allows you to push messages to somebody. With Kinesis, we were talking about how do I process real-time analytics, like real-time data. And then step functions is interesting because it fits with the whole Lambda API gateway piece, because step functions will allow you to orchestrate multiple Lambda functions into a workflow. And it will allow you to do it using a file, much like you use CloudFormation. So this will allow you to coordinate the consumption of microservices using a visual workflow. and it will basically act as a state engine. So it'll basically initiate and track each step. Sorry, my shoulder is bothering me for a second. So ignore me if I'm over here like massaging myself. So this actually acts as a state machine. So a state machine really is tracking state of various executions of tasks. That's what it is. So it has a set number of operating conditions that depend on the previous condition. So it's like, did this work? Great, let's move on. Did this work? Great, let's move on. Did this work? No? Okay, then let's stop, right? And that will determine your outputs. A vending machine, by the way, is a great example of a state machine. Customer puts in money processed and accepted. Display that customer, please make a selection. Customer makes a selection. Machine goes, grabs the selection, deposits it out, shares it, and then basically the user then gets a receipt or a message saying thank you, right? So with state machines, like step functions, you can create those workflows. Now, Amazon has a language called the Amazon States language. It's a JSON-based language that's structured that allows you to define and collect the various states, including the conditional states like choices or tasks. So this allows you to get into a stage or a state, execute a function or task as part of that state, and then do another task based on the output of that task that was in the previous state function. So just know you can actually orchestrate really complicated workflows using step functions. So like, here's an example. You're starting at the top. And let's say that you need to do two things concurrently. I need to check their address and verify their identity documents. Great. We did that. Is human review required? Yes. Then let's go over and let's wait for a review. Is the review approved? Excellent. Let's approve the application. Either way, whether we reject the application or approve the application, we might be at the end, right? So you can do parallel branches, you can do conditional branches, you can do fail succeed branches. You can do wait, say, I want you to wait here for a second. So here, by the way, is a more complex distributed workflow, which starts with a client posting data. And when it hits the API gateway, the start of that whole workflow might be, we're going to look up the customer number. We're going to generate a reference number. We're going to record the transaction that the client posted. Was that transaction successful? Great, let's end it. Was it a failure? Good. Then let's notify an admin and let's end this whole cycle, right? This is what step functions is for, is to orchestrate these kind of workflows. And notice there's 3 Lambda functions, a database, 2 databases actually, and SNS involved in that. Step functions is awesome for this. Questions?
Can you pass data between one step to next step
Oh yeah, absolutely.
other than just the state?
Well, and I would say that, like, can you like pass the actual data itself? I mean, you can pass like, like almost like variables down. But if you need
Like,
to
for
retrieve,
example, like here we have lookup customer number. Let's say I want to pass, once I have successfully get that, I want to pass it down to next step and maybe a step after. So can I do
Yep.
that?
absolutely, yeah, you can do that. But if it's a super large data set, you might have to like re-refer to it or store it somewhere else and then pick it up. But
Mhm.
like variable definition, easy, no problem there.
Is there a reason to not use step functions? Because I know I've done plenty of Lambda and Dynamo and SQS things, but we never use step functions.
Well, now come on now, Haley. We can always come up with reasons not to do things.
Yeah.
Yeah. Most of it, the time, by the way, it's a like either you don't have a good use case or people are just unfamiliar with it.
Yeah, I think that might be more
Yeah,
the
people are
case.
just unfamiliar with it. They might use a different orchestrator or they might use their own scheduling system to orchestrate the workflow. That's usually the case, is they actually don't need it or they don't really know that it's there.
Or they put a whole lot of logic into 1 or 2 lambdas and just chain them together.
And that's what we used to do, right? Yeah.
Like you can put all this into one Lambda if you wanted.
Yeah.
One big fat Lambda.
Right, and as long as it doesn't hit the 15-minute execution limit, what's the problem, right? Yeah.
Kind of talking about big lambdas. One that we did, it ended up seeming like because of the 15 minutes and a couple other things that we had a lot of logic for a whole bunch of tries and catches for it because of the so many different scenarios. I'm just wondering if that is kind of standard or is just something that my team could have done more efficiently. Just seems like there's a lot of things that can go wrong.
I mean, that would be hard to know without really like
Yeah.
taking a look at the code. I mean, because I've done this so many times where I'm like, why would someone do that? And then I've been in the position of doing something like that and then had somebody call me and be like, hey man, 2 years ago, you decided to do this with why would you do that? And then when I explain it to them, they're like, oh, that makes total sense.
Yeah.
But now we don't have those limitations, right? And so then the person in question was like, I'm going to go change it then because we don't have those limitations anymore. So without really looking at the code, it would be hard for me to second guess somebody else's like design and or coding decisions. But in general, typically we're just trying to figure out the most efficient, like shortest path to achieve the objective, right? And putting conditional logic inside of a Lambda function, nothing wrong with that actually, right? I guess the thing is that could it be more efficient? Could we leverage newer tools? Of course. But how often do we actually have the chance to actually go back and rewrite, refactor, recode stuff that we did? Because most of us are under date-driven deadlines.
Yeah.
I don't know how Travelers functions, but I'm sure you guys are under tremendous pressure to deliver, on time, right? Whatever that is.
Mhm.
So, yeah, I'd have to really like see it to know. But it's not uncommon for people to put logic inside of Lambda functions.
Okay, cool.
Yeah.
Thanks.
Yeah. There's nothing wrong with it, right? Good. Other comments, questions?
Just a general question about Lambda, because it scales all on its own. Is it possible that a Lambda would overwhelm like its backend database? But like, for example, like here Dynamo is managed, so yeah, I don't think that can happen here, but if you use your own or RDS that's sitting in EC2, is it possible that so many Lambdas get spun up that just overwhelm the backend?
Yeah, so Alex,
Like
you
an
broke
RDS,
up.
for example?
So I'm going to repeat your question back to you because you were breaking up there. So you're asking, is it possible for Lambda to scale so much that it actually overwhelms the database connections that you have against an
Yes.
RDS system, right? Which usually has a
Yes.
fixed number of connections, like 50, 100, 200, whatever, right?
Right.
Yeah, so there's a way in Lambda, oh, and my memory just let that go, is that there's a way in Lambda to create persistent connections and then reuse them. Like you can actually pick up the connection. I know that sounds weird, but like you can actually pick up the same connection the database had. That being said, yes, you can easily overwhelm a database, and it is actually the most common problem that I see between Lambda and its data store. If it's an RDBMS, is that you start 1,000 executions, and guess what? It tries to open up 1,000 connections, but the database only allows 500. And then what happens is you get connection refused, right? From the Lambda function, because it's not able to actually connect to the database in question. So that can happen. And there's a couple of different ways to solve that. Obviously, you can add a massive amount of connections, but here, do you know the problem of adding a bunch of database connections, like opening it up so that database connections can be available for an RDBMS?
Well, then you're eating up the resources of the RDBMS.
Exactly. That's exactly right.
Can't handle it. I don't know whether AWS solves that on its own, because you don't manage the infrastructure. So I don't know if there's like many masters and slaves running in the background.
For RDS?
Yeah.
Oh, no. RDS is EC2 based, right? So just so we're clear, if you have a primary and a secondary box, you've got 2 boxes.
Oh yeah,
right?
yeah.
That's
I guess
it.
Dynamo is different.
Dynamo doesn't run into that problem. If you set Dynamo to auto scaling, you're not going to run into a database connection issue, right? I think you have to get to, I want to say it's like 10,000 concurrent connections against a single table before it starts to throw errors at you. That's a lot, by the way. And if you're hitting a single table that much, anyway, a whole different discussion. With RDS, the way you solve that, by the way, is you have to turn on enhanced monitoring so you can actually see the number of connections and memory consumed and all that. And you can actually set up a trigger to say modify the DB parameter group inside of RDS so it can scale the connections and then scale them down as it goes down. But that's all logic you have to write yourself. That's not something that AWS will do for you. There's no mechanism to auto scale RDS outside of Aurora. So yeah, you have to solve that problem yourself, unfortunately.
Oh, you're saying if you use Aurora, then that solves it?
It's a little less of a concern because it will actually scale instances as you need to. You still have to modify the DB connection pool, but you won't run into a capacity problem. In other words, if you scale up to 5,000 connections, it's going to add more horsepower to support that. So it's a little different beast with the serverless version than it is if you're using the EC2 based versions of Aurora and the standard RDS systems.
Okay, all right. Sounds like a bigger topic then.
It's a big topic. Just so you know, there is a planning and designing databases on AWS class, which is absolutely spectacular, of which they do talk about those challenges inside the course. So I'm not plugging the course. I don't teach it. I'm just letting you know it exists. Yeah. Good. Okay. All right. So then let's do a little knowledge check then, and then we can do a lab. And then guess what? We're pretty much a lab. I think we can cover backup and recovery quickly, and then we can just go into our capstone lab. All right, so which type of Amazon SQS provides at least once delivery? Good. Yeah, it is a standard queue. So good. I see people putting that in there. Right, standard queue guarantees at least once delivery. FIFO queue, right, guarantees the order messaging. It will also guarantee at least once delivery, but it also guarantees at least once processing. What is an advantage of long polling over short polling? I mentioned this, is that it's the one thing it kind of like changes in the sense of like something reduces when you use long polling. Something goes down. Good. I see 2 people posted responses basically about reducing costs, and that is dead on, right? It does reduce costs. All right, what's the feature of Amazon SNS? All right. So I see some C's. SNS can push messages to multiple subscribers. Is that true? And the answer is yes. Oops, it is. Okay. We're in our final run of 2.5 hours here. Now what we're going to do is we're going to build a serverless architecture. This time we're actually going to do lab 5. So here, by the way, what we're going to do is you are going to create an SNS topic. You're going to create Amazon SQS queues, and you're going to subscribe the queues to the SNS topic. Word of caution, the console has gotten way better at this, but make sure you are not changing regions every time you open up your browser, okay? If you put an SQS queue in like Virginia and your SNS topic is in Oregon, it's not going to work. Don't get me wrong, you could eventually get it to work, but you're not going to get it to work in the lab. So after you create your SNS topic, your 3 SQS queues, you're going to create 3 Lambda functions, and then you're going to upload an object to your S3 bucket and then validate the process file that goes through this entire process. Okay. So if we go look at the lab itself, first of all, go ahead and hit start lab if you haven't already done it for me, just to make sure that you grab it before it expires. Create an SNS topic, create SQS queues, create an S3 event notification to SNS, configure 3 Lambda functions, and then upload your object. So let's see, this lab is usually allocated about 45 minutes. So it is like 2:36 right now. So we're going to check back in around 3:15. As usual, put your checkbox up there. If you're there, I will clear it out to make sure that everybody's feedback is good. So let's go ahead and get started on lab 5. And let's build a serverless architecture. I have to step away for literally just 5 minutes. I will be right back, but I will answer questions as soon as I get back. Sorry. Let's talk about this last little piece. So, all right, so we're at the end. So I'm going to leave as much time as possible for the lab. It's technically, you know, somewhere between 60 to 120 minutes, just depending on how fast you are. So I'm going to kind of skim this one a little bit more than I usually do, just because I want to make sure you have plenty of time to do the lab. Now I'm going to go ahead and kick the capstone labs up to make sure that they are launched. Hold on one second. I don't think I'm sharing my screen. I just read a really crazy article, which I'll have to tell somebody else about at some point in time on AWS. All right, so capstone lab, lab 7, activate lab, and pre-warm. Good. Okay. Wow. Let's get into it. All right, so we are on the final kind of chapter here, and this one, we're going to skip that question just because of time. And then, you know, this whole section, this module is really about disaster planning and backups. This is really about DR. The idea here is like, how do we basically prevent data loss and service disruption? Like, how do we recover services? This comes in 3 kind of general questions, which is like, how do we do disaster planning? And then what are our recovery strategies? That's what I was referring to earlier, is that that's really kind of just broad strokes around like different ways to approach the topic. AWS backup is a dive into the specific service. So with disaster planning, you know, Warner Vogels is quoted for like, everything fails all the time, right? And so it talks about like all the general thoughts that you want to have around approaching disaster recovery, like fault tolerance, like high availability, like running things in 2 regions, like having backups, service availability, that kind of thing. So, you know, this includes duplication of, you know, services and data as necessary, but it also includes these 2 concepts, which are probably important to just mention for just a second, which is recovery time objective, which is basically how much, like, you know, basically how often does data need to be backed up, right? So in other words, it asks the question, how much data can the business lose, right? That's really what it asks. How much data can the business lose? 12 hours of data, 24 hours of data, a day's worth of data. And then there's the recovery point objective, is that how long can the service be unavailable? So RTO says, how much data can you lose? Can you lose 12 hours? Great. We probably need to do backups every 10, assuming backups take 2 hours, right? We can only lose an hour's worth of data. Then we probably need to take backups every 30 or 45 minutes, right? If you're like, hey, you know what, we can't lose any data, that's a whole different consideration. So you're going to be doing backups continuously, right? Duplicating data continuously. Downtime says, how long can the application be unavailable? Which basically says, if the answer is, well, it can be down for seconds, then you're going to need a failover mechanism. So you're going to be running redundancy, pretty much active redundancy. If it's like a minute, 2 minutes, 5 minutes, 10 minutes, then you might be looking at something a little bit more active passive. But RTO and RPO, the concept of how you attend to this from a data perspective and a service recovery perspective is pretty much the focus of this entire module. So there's a bunch of services that will help you, especially from a disaster recovery standpoint, help you in duplicating your storage, right? Help you with, you know, recovering AMIs, recovering container images, recovering your Lambda functions, which ideally are zip files, are already in repositories, right? And then how do you like set up your networking for failover? How do you set up your databases for failover? And then, basically, how do you make everything infrastructure as code so you can reproduce it? So I'm sorry, I know that was the quickest skim I've done thus far, but it's all in here for you to read, including the notes. But I just want to make sure you saw that. I'm actually going to skip the backup section because that might be the most important. And I'm just going to drop over for a second and talk about recovery strategies. I just want you to know that this is here. This is all over the exam, by the way, for architecture. But what this is these are different backup and restore kind of like DR scenarios that you can use inside of your AWS account. But these are industry standards for the most part. Things like cold like restore after your service fails, which of course takes a long time. Having a database, which is a pilot light, ready for scale, meaning it's running continuously, receiving updates. There's also a version of having a low capacity active standby, right? Maybe it's a recovery option. And then there's a full multi-site active data, replicated in real time. There are these options. Now, Amazon does have a data migration service, disaster recovery service called Cloud Endure. It's a company they bought. The main thing I want you to know is that this slide is here, which shows you the different RTOs and RPOs that you need to memorize if you go to take the exam. This will actually show you like which one is going to do it real time, which one is going to do it in minutes, which one is going to do it in tens of minutes, which one is going to take hours, if not days, to restore data. It also shows, by the way, which ones are the hottest in terms of availability and which ones are the cheapest in terms of costs. So I just want you to know that at the beginning, that's where you can see the RTO, RPO definition, that first module, submodule, if you will. This third submodule gives you all the details about the different scenarios you can use in and outside of AWS. Now let's go back to AWS Backup for a second. So AWS Backup is a tool that says, how do we back up all of our data inside of AWS? How do we create an automated way to do this? We used to have to write scripts that go to talk to the API and pull data out, or we had to buy third parties, which is still valid actually. Using third parties to back up your data is a great strategy still. So AWS Backup is a centralized and automated data protection service where you can actually set up policies, and it will actually go and back up things like your DynamoDB tables, RDS databases, hard drives, all your file systems. This is really a data protection service, right? So this will allow you to configure, manage, and govern all of your backup activity. And it will work across your accounts in all of your services that it supports. It doesn't support all the services, but most of the data services are supported. So, it does actually integrate with Storage Gateway, which would allow you to back up things on premise. But mainly it works with, EFS, FSX, EC2, DynamoDB, like all the data stores and whatnot. Now, it doesn't do the fringe data stores. So if you got stuff in like Neptune or whatever, I don't believe yet that backup supports that. So just know, though, that this backup service will support a lot of policies and is expanding in its service capability all the time. So, just know that you can set this up, follow the policy. You can run it on a schedule. It can even be triggered if you want to, so you can do that as well. AWS Backup, just so you know, complies with a number of security compliances, including PCI DSS, ISO 27001, 27017, 20018, and it is HIPAA eligible. So just know that it can meet some pretty semi-stringent security requirements. You create a backup plan, goes into a vault. That plan runs on a periodic basis, so you can see the snapshots of your backups. Everything is encrypted, by the way. So you can actually set that up you can deepen that if you want to. When you create a plan, you basically determine the timing and the frequency. You set the permission, so a role is used to actually have the backup service talk to these other services. Define the timing of the movement and period of retention within a backup by a lifecycle policy. And then you can assign resources to the backup plan, either using tags, or you can actually use ARNs, which are very explicit resource names. And then, from there, it's just a matter of kind of managing and monitoring your backups to make sure they're working. So that's AWS backup. Now, before we roll into the lab, I just Oh, good. It wasn't just me.
Oh,
I was thinking the same thing. Yeah, he just kind of stopped.
Oh.
He's still, shows he's still on here.
Could be performance art. So can I gonna run in close? Hi, was that me or did everybody get kicked out?
Just you.
Sweet. I love it. When it's just me. All right, so I'm going to check with the learning and development team to get how they want to assess the class. The other thing to note, and I'm not going to bother you with this, but I'm going to give you tons of resources, including one thing that I want to just show you before I launch you into the capstone lab. So AWS, when you want to study for an exam, makes these ramp up guides. A lot of these are co-authored by myself and a couple of other AAIs. So just know they're pretty comprehensive. But if you want to take the Solutions Architect Associates exam, just know that they have these guides. And Firefox is so funny about this. They have these ramp up guides that you can use to get access to free training and resources to supplement what you've taken here in class. The other cool thing though about that ramp up guide site is that if you need to know more about containers, there's a guide for that. You need to know more about IoT, there's a guide for that. You want to know more about databases or migration or whatever, there's a guide for that. And these guides, by the way, give you all of the AWS free resources to go deeper on the topic and allow you to self-train like on the things that you need to know. So there is a solutions architect guide, right? Which will you don't need to necessarily memorize all of this, but you definitely need to skim it at least a little bit. Because as I mentioned before, taking the architecting class is not going to get you all the information. Plus, did you really take in 100% of the information? Right? I know it took me a long time to get everything. So just know that if you need extra immersion, there's tons of white papers, digital trainings, really good stuff here to drive things home. If you're going to take the exam, this is a great way to study for it. We barely touched, for example, on the well-architected framework. That's something you probably want to at least skim the white papers for. And then note that there's self-paced labs here as well. So more public quick labs that you can do that can keep you trained. They usually cost a couple bucks. And then notice that there is an exam guide and then there is exam
Mike-
readiness training as well.
Mike, are you sharing your screen?
Oh, yes, I forgot. That would probably be helpful, wouldn't it? All right, here it is. Thank you. Let me go back. So this guide is a PDF file that you can download off of this particular site, Ramp Up Guides. Let me share this so you can see it. This, by the way, contains serverless, storage, media services, machine learning, and then this is just the technology section of the Ramp Up Guide. Here it is by role. So if you want to become a stronger developer, this Ramp Up Guide will actually help you on board to a bunch of free AWS resources. And this is what I was referring to, is that here are the resources. Why are you scrolling? Stop for a second. So resources like web pages, videos, classroom, well, that's classroom training, so maybe I take that, including things like the exam guide, digital training on exam readiness. It will usually take you about 40 additional hours of study to pass the Solutions Architecting Associate. Usually people do it at 5 hours a week for 8 weeks. So just know that this Ramp Up Guide, which is literally the architecting guide from this site. So I clicked on this link over on the left-hand side. This guide will take you all the way to associates and to professional. So download these guides if you either need to train up to pass your exam, or if you just want to know more about a particular technology like containers, there's a great guide here. And if we download this guide, right, it's going to show you everything you can click on that's free to get deeper and better training in containerization on AWS. So I just wanted to share that with you before we rolled into the lab, because I think it's important that you have the resources. Now I'm going to send this to you in an email. You obviously just posted the link to the ramp up guides. I'm also going to share an email with all of the resources like EKS workshop, ECS workshop, EC2 spot workshops, free workshops that can actually add more training into the equation. Okay. Other things to know is that you will get my email, but if you need to contact me for any reason, I am one of the most consistent trainers that trains for travelers from WebH Solutions. It's me and one other person. And so just know that, you know, I can support you if you have any kind of like particular challenges or issues like around training or guidance or whatnot. And so I just wanted to share all that before I unleash you onto the Capstone Lab. Any questions about this guide or the ramp up site? Okay. All right, so let's take a look here. Oh, well, we're going to end this one just over here. Eating resources. Okay. So in this last lab, this is Capstone Lab, and doesn't look like it loaded up properly. Let's see. Weird. Let's click on start and see what happens. Huh. Is anybody else only getting a single page loading up when they click on Lab 7?
Yes.
That's fun.
Well, it says click for the supplement, right? For instructions.
Yes, so they're probably going to want us to go through and, oh man, that's crazy. They've never done that before.
Yeah, same.
That is interesting. By the way, this is also in your like student guide. So like if you have if you registered yourself for bookshelf.vitalsource.com, you'll have access to your particular guide. Hold on one second. This is where you redeemed a license code in order to get access to the materials. There is a lab guide in here. Where is it? 7.01. This might be more accessible than the skill builder, but let's check and see. Wow, I can't believe they did that for just one of the labs. That's really strange. Anyway, lab 7 is right here if you've got access to the guide. And wow, they did the same thing there as well. Okay, that is really interesting. Okay. So Capstone Lab. All right, so here's the capstone. So I guess all the materials are now listed here. So you're going to need to log in to bookshelf.vitalsource.com. My apologies. That was this is the first time they've ever done this in the history of teaching. So you will actually need to log into Skill Builder as well to get access to this. So this includes the lab overview, which basically is the task 1, 2, 3, 4, 5, 6, and 7. Task 1 actually has you reviewing and running a pre-configured CloudFormation template. Then you're going to create an RDS database. And then you're going to create a caching system for that database that you just created. And then you're going to create an elastic file system, and then an application load balancer, and then create a launch template for your EC2 instances. And then you're going to create the application servers by basically setting up auto scaling, including the load balancer, CloudWatch, and a scaling policy. And that's it. That's going to be pretty comprehensive, actually. I believe you're setting up a WordPress. Yep, there it is, WordPress servers. So yeah. Are some lab hints if you need them, because this is pretty like free form. And you can choose the lab instructions button to navigate to the lab instructions. This actually allows you to build it step by step. If you are new to AWS, my recommendation is that once you get logged into the supplement, is that you scroll down to task 7 and click on lab instructions and just follow the lab instructions. If you are not new to AWS and you want the challenge of kind of navigating this by yourself, feel free to do that. But I would recommend if you're relatively new to AWS and haven't run production workloads, that you actually just run the instructions, which are step by step from what we've done before. Okay. But your call. Okay. So I know that kind of threw people off, definitely threw me off. So open the supplement, get logged into Skill Builder. By the way, you can use a standard Amazon.com login if you want. It might ask you to verify that you want to do that. Is there anybody who's not able to get into the supplement at this point in time?
Michael, to log in, I cannot use my company email address. I have to use my personal email address. Would that be a problem?
It's not a problem.
Okay.
Yeah, I use my personal address. I didn't use my company email address.
Okay.
Okay. All right. So here we are. We've got 70 minutes to execute against this lab. Let's take a run at it. Let's see how far we can get.
Still trying to navigate the skill builder. How did you get in there? There's the about this course, materials, additional information. Well, how did you get in?
Alex, share your screen for me if you don't mind. So see where it says enroll on the upper right-hand side?
Ah,
And then you'll log in with Amazon.
okay.
And then if you have a login to Amazon via this, you can use it.
Okay. Got it. Okay, thanks.
Yeah, that should work there.
It's a different account. It's not the Quick Labs password, right? Not that account.
No, that's an Amazon.com account, Anastasia. So,
Oh.
so you would use either your personal Amazon.com login, or you can create a new one if you want.
Mhm.